exploratory data analysis, right? So here in this video we're gonna learn all about this thing, all about this big buzz, right? So here, for example, we're gonna understand loan default analysis, right? So in EDA we will be studying a loan default data. Here you notice this one word default. Now if you are someone who is not familiar with the banking terms, then this particular word might be bothering you. Don't worry about it. I'll just give you a simplest example in absolute layman term, no technicalities into that. All right, so in very layman term, let's say you are paying certain EMI and you missed that EMI continuously for 90 days, right? For 90 days you are not paying that EMI. That's where you turn out to be a defaulter, right? So the moral of this story is, if you miss to pay the EMI continuously for next 90 days, you turn out to be a defaulter. This 90 days will vary by bank or by product. All right, so this completely depends on which bank, from which bank you have taken the loan and what sort of loan that you have taken, right? Mostly in general it is 90 days, but this varies by bank and by product. Okay, so in this analysis, this is not a subject to study whether it's going to be 90 days or not. What is the study point? The study point would be what sort of customer can turn out to be defaulter or non-defaulter. Okay, so for this, what we're gonna take is, where we're gonna get the data, that's from the Kaggle. So in Kaggle, on Kaggle we have this data set, right? This is very much similar to the real life banking data. Okay, so if there is someone, if you have some friend working in banks in analytics domain, you can check with them. This looks very similar to that. Okay, so this sort of data we are going to use in this. The data is 571 MB, 3 files we would have, which we will be using for analysis. About the data we will explore more in the coming videos. All right, so what next do we have in this video? Why this video is so long? Okay, not this video, means the series is so long. We are going to make a series of somewhere 10 to 12 videos, right? So we will continue, we'll try to cover end-to-end thing. If you are beginner, then that's going to be very useful for you, and if you are on intermediate level, then still it's going to be very helpful for you. Or if you are someone who are still in your comfort zone but trying to come out of that, but if you're not getting the real opportunities to work on that and explore on that, then still it's going to be for you. Okay, so what all we are going to learn in this video? The things which we will be learning is feature selection, feature engineering, missing value imputation, binning, variable derivation, all right, variables segmentation, data exploration, behavior observation, insights derivation, visualization, and many more. All right, isn't it exciting? Yeah, it is. Okay, so just be with us, right? Just stay with us and follow this series. You will really enjoy and learn a lot. We're gonna have a look in this data. This is loan defaulter, which is basically providing you the data for all those customers who had taken the loan or either paid completely or defaulted on that. Using that, we're gonna do our exploratory on that data itself. We're gonna do our exploratory data analysis, and and we're gonna make our conclusion. All right, so how to get this data? First of all, let me show you what all are the data that we have. Here is the application data, then previous application data. Application data is something which we're gonna use to make our conclusion. Previous is something we're gonna use for reference, and then here we have the column description, whatever columns are available in this and in this table. You can download this data by clicking over here or over here. When you download this, in your download folder, you're gonna get this kind of data, this like this. All right, so as soon as you are done with that, then you can extract that and store that in a folder. So like the same way I have done it, here is the application data and here is the previous application data. Here is the column description, which is comma separated. I have converted that into the Excel, which is nothing but just a save as thing. All right, I have here column description file already opened. In that I have created these 2 additional columns. You don't need to worry about this. All right, no, I think yes, these 2 columns I have created additionally, so you don't need to worry about this thing. This is exactly the same. This is the column name and this is an ID variable which I have created for my use. All right, you don't need to worry about. You can just continue with these 3 variables. All right, now moving forward, you in your data you would also be having the table name. Here is the table name, then column name, and then the description. All right, so let's just go to the data and try to import all these 3 things, not 3 but 2, this application data and the previous application. Okay, so I'm taking you to the Jupyter notebook. Here in the Jupyter notebook we are going to do this analysis in all this segment. We are going to cover all these things, which is data import and basic exploration, feature selection, feature engineering. When we do feature engineering, we're gonna cover missing imputation, value modification, and all these things. All right, and then after that we're gonna do data analysis, and then we're gonna make our conclusion or insights. Isn't it interesting? Yeah, it is. I can hear that. So let's just start with importing the dependencies. All right, so first thing is import pandas as pd, import numpy as np, import matplotlib.py plot as plt. Then we're gonna say import seaborn as sns, and then there are some of the more dependencies. I'll just show you. Let's take it one by one. Okay, so we are done with importing all these modules, all right, which would be required. Okay, now after this what we're gonna do is we're gonna import the data. So first let's import this file, this application data. Okay, so for that we're gonna say pd.read csv, and then inside that we're gonna put the location. Then here I'll just come and I'll copy the file name, application data dot csv, not b, it's v, and then I'll copy this and then I'll say previous app. I'm just trying to import both of the files, nothing else, no rocket science. It's very simple. You just have to follow the same step if you are absolute beginner, right? See, I'm making this video from the perspective of an absolute beginner. If you are someone who knows all these things, you already know all these things, then either you can skip this part or you can watch this in 1.5x or 2x speed. All right, so let's just import this. When I hit enter, this is going to import it. It's gonna take a few seconds. Let's just bear with this. All right, now we are done with importing these 2 files. Now let's have a look one by one. So here I'm going to say app.head, and it's gonna show us 5 observations. Now you can have a look on this observation. Now let's say this is the column which I don't understand what this target column is. Okay, so what I can do is I'll just copy this column name, will come over here, and in this I'm just going to put this, and then I will see. So here target means it is simply telling you which customer is a defaulter and which one is a non-defaulter, nothing else. So this is how I'm just trying to show you how you can refer to understand the column name. Now we are done with this thing. All right, so the next thing which we're gonna do is feature selection. How we can do that? Let's just try. So we're gonna start over here. So let's just say app.columns. Let's have a look at the list of columns. Now here you can see we are not able to see all the columns. So here is some option we can try putting right over there, and this will enable pandas to show all the items. Let's just see if this works on this. If not, then still it's fine. That's not an issue. All right, so now here we have a list of columns. Let's try to have a look at its shape. 307,511 rows and 122 columns. That's what we have. Are all these columns useful? Let's just have a look. So we are first going to check in all these 122 columns, how many columns are there which has the missing values, and what proportion of the total rows the missing values are. Okay, let's just see. app dot is null, you're gonna say simple. This is very simple thing. All right, so you just use this and you're gonna have a list of all the columns. So here you see this is this particular column, name, type, suit, right? So this has 1292 missing rows where the value in this particular column is missing. Now if you see, this is not arranged, somewhere it is showing missing, somewhere it is not showing missing. Where you see 0, that means there is no missing value. All right, so what we're going to do over here is I will just try to sort this thing, sort values. All right, and let's just see, now it is sorted and it's looking pretty well. Here we can see all the columns which has missing value at the bottom. Now let's just do one thing, I will just put this in a data frame. All right, so let's say call missing info, or let me just call it msng info, missing info. All right, and here I will just say pd data frame. Let's just enclose this, let's just take this over here and let's hit enter. So here we go, now we just managed to make a data frame out of it, but you see we don't have the column name. So for that, let's just say reset index. And now what we're gonna have is this. Let's rename these two columns. So here we will say just columns. Oops, again I hit tab, and then here we're gonna provide a dictionary. Let's take this. Inside this I will just say call name. Call name means column name I'm trying to say, and over here we have the column name 0, and then here I'm just going to say null count. All right, so I guess it's pretty well. Now let's just say in place equals to true, and let's just have a look at the head. Bravo, we are done with renaming this. Now the next thing which we're going to do is we're going to create a percentage of this. So what does that mean? Let me show it to you. For example, here you see the data. All right, so here you see this many missing records are there, but we are not able to conclude what proportion of the total rows is it missing, right? So here we have 307.5 thousand records in total. Out of that, these many are missing. So let's try to calculate the percentage of it. All right, so let's just say here I'm just going to use this particular column name. I will say null count. Let's just put right over here, and I will divide it with total number of rows. So what is the total number of rows that we have? Here you see we checked that using shape function. So I will use the same and I will pick this element. So for example, if I do this and if I put this 0, then I'm going to get first element. If I put 1 over here, I'm going to get the second element. So I require first element. Okay, so I will be using 0. Let me take you back over here, and here I will just say app dot is dot shape, and here I will just take 0, and let's just store that in a separate column in the same data frame. Over here I will just say missing percentage. All right, I'm just using abbreviated form, which is PCT. I'm not sure if that makes sense to you. All right, so I just need to put this in quotations. All right, now let me just take this and I will print the top 5 records. Okay, so let's just try to hit enter. So here we got. All right, let me just print the whole information instead of 5 because it's not making much sense. Okay, now let me just show you. Here is what we got. Now I will just try to convert that. I'll just do into 100, and let's just see. Now this is looking like this. Now let me just round it up. I'll just do, or let it be. I will just keep it like this only, so that it gives us a perfect information, right? Because many of the time when you see the columns like this, so like this, so if you just round it up to 2 digits, then we won't be able to get this information. Now what I'll do is I'll just export this data in Excel so that we will not have to do scroll up again and again. Okay, so I will just say to Excel, and here I will just export this in the same folder over here. Okay, now let me just put it right over here, and I will call it missing info dot xlsx. All right, and here I will just say index equals to false. All right, and let's just see. I'll just say hit. Okay, so we are done with exporting it as well. So here is the file that we got. Let's just have a look. Here is what we got. I'll just do some modification into it. I'll just phrase span just to make it more navigable, right? Let me just do this and do this. Okay, now let's just have a look. So if you see over here, all these columns, all columns have the missing records more than 40%. You see, these all columns have records more than 40%, right? So we don't require these columns in our data. Columns which are having the records more than 40% will not make much sense to us, and we can't end up, you know, making it usable by just imputing the missing values. All right, so let's just drop this. We are going to start. Okay, all right, so we will start feature engineering. So in that we will include missing imputation and all those things. All right, so but this is still the feature selection, so I'm just going to take it right over here. All right, so what I'll do is let's just start with dropping these columns. Okay, msng info, no, app data. I'll create a separate data frame which we say app missing removed. App is the data frame name, and here I'm simply trying to say that out of this data frame I'm done with removing the missing columns. Okay, all right, so when I say missing columns, it means only those which has missing values more than 40%. all right, now after that I'm going to say drop, and in that I require to supply the list of all those columns which has the records missing more than 40%. So how can I do that? So for that I need to filter those columns out of this data frame. Okay, so how can I do that? So let's just say first thing which we're gonna do is right over here missing info, and in that again I would say missing info. Right over here I will just use this, and I'm just trying to filter this thing. Okay, so I will just say which is greater than 40, right? So let's just see what happens. Oops, there is some error. Missing info p is not defined. So why did I use p? Missing percentage is not defined. How come that could be possible? Okay, I just need to put that into the quotation. I'm sorry, I'm making silly mistakes, just bear with me. Okay, so this is the list of the this is the subset of data. Now I only require this particular column, right? Call name. Okay, so I will just put over here call name, and here we got. But now this is series. I need to convert that into the list. So I will just say, let me come back over here, just right over here, and here I will say missing call dot to list. All right, missing call, and let's just see. Now these columns are converted, that series is converted into the list. Let's just see the total number of columns into it. These are 49. These are quite huge in numbers, isn't it? But yeah, this is how it is, right? So let's just try to drop all these columns. So here I will say missing removed dot drop, and here I'm just going to supply labels, and that will be missing call. All right, missing call, and then axis I need to say 1, and then we will see the shape of this data frame. Here we go, we have just 73 columns remaining, right? You remember previously we had 122. Now we are done with that. Let's just have a look at the sample data. We will just have a look at sample data. Let's just call it head, and here is the simple sample data. And now in this table, what I'll do is whatever we just removed, I'll just mark them red, so that we will use that as a reference. Okay, now after this, if you see over here, there are certain flag columns. Let's try to investigate these flag columns. Okay, so first thing which we're gonna do is we're gonna filter out, we're gonna make a list of all the flag columns out of this data. How can we do that? So let me just call it, I'll just say flag call. I'm going to create a blank list, and then I will say for call in the data frame name is this dot columns. So remember, this will give the list of columns. If call dot starts with flag underscore, then what I want it to do is just append that into this particular blank list. Flag call dot append, and inside that call. Okay, now once this is done, we will have a look at this flag call. Let's just hit enter. Wow, we just got this. We just got the list of all those columns which starts with flag. How many columns are there? Let's just have a look. 28 columns. Now we need to explore these columns, how these columns are looking like. Okay, so let's just try to explore these columns, the data out of these columns. Okay, so I will simply say app missing, and here I will just apply the list of columns, flag call. Okay, and I should rather say head over here, so that it will be quick. Now this is the column. In this, if you see, these are generally flagged. For example, if you see flag document 13, what does this mean? So I'll just copy this, and I'll come back to this particular file where we have the column description, go inside this and try to put it over here. And this over here, see, it is nothing but simply saying there are, let's say 20 documents were required, out of which 13th document was either submitted by the client or not. That's what it is telling. Okay, so we will start with looking into each of the columns, how significant these columns are in relation with the target column. Target means whether that's a default or non-default, and then we will try to take a decision on that, whether we want to drop or not. See you in the welcome back, everybody. So now here you can see these are the flag columns, and we have the sample data for them. Along with, we want to check the relation of these columns with the target variable. So here I just need to take a target column as well, right? As of now we have just 28. Now it will become 29. So target column we have in the original data. So as original data name is app, and out of that we just want to take target. All right, and here's what we got. Okay, and let's just hit enter. Oops, this just gave us the error. Okay, of course it will give us the error, because here we just need to use, let's call it, okay, let me just use the same table over here as well. Let's just see. Oops, this is still giving us the error. Let me try to have a look. So I think without this it will work. All right, so here is what we got. Okay, this is target column and rest of the flag columns that we have. Now what we need to do is we will just store this in a separate data frame. Let's call it flag and target columns. Okay, and let's just flag and target columns. Okay, and let's just take this, and here we will just see at the we just have a look at top 5 rows. Now let's just try to find their relation, or maybe what we can say it, let's just try to plot this in context with target. What is the distribution, how the distribution looks like. So first of all, I'll just try to create a simple one. So let's call it sns dot count plot, and inside that data equals to flag target call. This is the data frame which we want to use, and then we want to use which column. Let's pick any random column, let's say this one, and over here I'll just put this is going to be on x-axis, and then I want to see in context of target, so I will use hue, and here I will just call it target. Okay, now let's just see how does it looks like. So here is the data that we got. So it simply says flag 19, whoever customers, all the customers who have not submitted this, most of them, or in fact we can say all of them, are non-defaulter. So target column is something which is representing whether the customer is default or not. When target column has the value 0, that means the customer is non-defaulter, and 1 means customer is a defaulter. So here 0 and 1, this corresponds to this flag document 19 column. So if this column has value 0, that means customer has not submitted flag document 19. Document 19 is not submitted. So looking at this, we conclude that the customer who has not submitted document 19, most of them, in fact we can say all of them, are non-defaulters. This is what the conclusion we are getting over here. So let's try to repeat the same thing for all the flag columns. So all the flag columns we have stored here in a list called flag call. So what we will do is we will loop through each of these columns and we will try to plot this thing. So how many columns that we have in total? 28. So we're gonna create 28 this kind of charts over here, or visualization over here. So we would plot them over here, let's say 4 in each row, 7 rows and 4 columns. Okay, so what I'll do is I'll just say okay, let's just start with very basic. Okay, I'll just say for call in flag call, and here I just want to say plt dot subplot, and in subplot, okay, here I will have to do one thing. For I call, I'll just explain you what does this mean. Enumerate. So now if you are wondering what does this I call means or enumerate means, so this is nothing but when you do the looping this way, what it will do is whatever list you have, it will print the list and their index position as well. Let me show you how does this looks like. So I'm simply going to say print I and call. So let's just see how does it, like you can see column name and their index position. So this is why I'm taking this. Okay, now I just hope that this is clear. It's not a big thing, and let's just see over here. All right, and just right over here, we're gonna say plt dot subplot. In plt dot subplot, what we simply say is how many rows or column that we want. So we want 7 rows, 4 columns, and the first element for which I need to do this, so it will start with 1, and then it will say second, third. It will just keep on telling that which count of plot is this. Okay, which number this plot is. Okay, now here if you see, I have hard coded this column name. So instead of that, what I'm going to do is I will just use this call. Let me just use this right over here, and let's just try to plot this. Let's just see how does it looks like. It's gonna look terrible, I'm telling you. It's taking time. Till the time, I'll just pause the video. Alright, like you can see, this is looking horrible. Alright, so let me just make it fix. Let me just do a fix of it. Okay, plt dot figure, and inside that I'm going to say fix size, and here I'll say 15, comma 5. Let's just plot this. It's gonna take few seconds, so you'll have to bear with it. Okay. All right, so here is what we got. I still feel that it is not clear, not pretty clear, so which is indeed right. Let me just make it 15 itself, and let's just see how does it looks like now. Oh god, it's taking too long. Here is what we got. Still not very cool. It's not looking very good. Let me just make it 20. Sorry, 20, and here as well 20. Let's just see how does it looks like now. I'm sorry, it is taking too long. Still better, but we can do much better. Let me just try to do much better. I'll simply make it 25, and let's just see. Again, it's taking some time. All right, so here is what we got. Now for now, just ignore the first 8 plots and let's focus on the remaining one. So if you see over here, flag document 2 and all these things, so except flag document 3, in all of them almost we don't have any customer who has submitted the document, almost, right? So that's what we can conclude, that wherever the customers are not submitting those documents, they are most likely to be non-defaulter. Almost all of the time they are non-defaulters. Okay, so that's what we conclude. So in that scenario, we don't have much importance of these variables. Now let's just focus on these tables, these plots. Okay, so here we have n and y both, right? N and y and n, etc, etc. So first what I'll do is I'll try to see the correlation of these variables with target variable. How does that looks like? Okay, so for that what I need to do is I'll just take these variables from the top. Here is there must be a list of all these variables, flag variables. Okay, flag, target, call. Okay, here is what I have. Okay, or let me just take this one. Let's just take this and come back over here, and here I'm just going to print this one, and out of this I require only these columns, this set of columns. That's it. And one more column which I need is targets. All right, let me just arrange it a little bit so that it looks good. Okay, and let's say flag for correlation, flag to check the correlation, and here I would just say, let me include one more variable. I would say there seem to be some problem. List indices must be integers or slices. Okay, I don't need this. Okay, and over here what I'll just do is target. So these are the columns which we require. Okay, and these columns are available in the data frame. Flag, let me just create a flag core df equals to, I'll take the data frame. The data frame which we have is this one. Let's just utilize this over here. And we will just have a look at top 5 observations. So here is what we got. Okay, all right, so now we have to find the correlation of these tables, okay, these columns with target column, or maybe with each of the column you can rather say. All right, so let's just try that. Okay, so I'll just say core, let's hit enter. Here is what we got. Let me just round it up, round, and I'll just say round it to 2 decimal places. Okay, now let's just put this in a data frame. Okay, I'm just trying to put it in a data frame so that we could plot a heat map on this. Okay, core df. All right, so inside that it is stored, and let's just hit enter. Here is what we got. I'll just try to plot a heat map. Start heat map, dot heat map, and inside that let's just put this. We will do some formatting on this. I'll just say cmap equals to cool warm. This is nothing but a color theme. Okay, let me just set the figure size as well. plt dot figure, again the same thing I'm doing, and here we'll say fixed size. Like I said, I'm taking it in an absolute beginner way, right? So if you feel that it is too slow, just try to watch it at 1.5x or maybe 2x speed. Okay, so here is what we got. Now then I will just say line width, I will say 0.5, let's just, and then anode equals to true. Well, so here is what we got. Now we need to see how these columns are related with target. Okay, so if you see, this particular column has 0 correlation with target. This one 0.05, this one 0.03, this one 0, again 0, this one again minus 0.02. So now you must be getting question, what is the considerable correlation? So that is between minus 0.8 to plus 0.8. That's not something which I am telling you. If you don't trust me, here is a website. I'll just show you that. Okay, this is as per that's as per Investopedia. All right, so I'll just show you, I'll just give you a view on that. So here is what you can see over here. Correlation coefficient values less than 0.8 or greater than it are not considered significant. Okay, so we have to be careful about this ratio, right? So if we are getting something in range of this, then that is useful, otherwise that's not useful. So like you can see, these columns are not of much use. Okay, now this, if you see, we are seeing for only flag mobile and this flag phone, mobile phone, but there is something which is missing. What is it that is missing is here flag own car and flag own reality is not showing over here. There, why? Because these have the object value and y. So let's just try to change this thing first. Okay, so how can we change this? So for that I'm just going to treat this little bit. I'll have to do, so why I'm showing you all these things, just because so that you'll get a complete idea how the things works. Okay, not over here, I'll not do over here. I'll just try to, let's just put this in a separate segment. Okay, all right. Now over here, what I'll do is, let's just take this. So if you want to have a look first, how many rows are there for this particular thing, first I'll just help you have a look with that. Dot group by, and over here dot size. So you see, for there are 202,000 customers who does not have own car. Okay, so let's just try to replace, and same thing I'll do for reality as well. Okay, so I'm just directly going to do this thing. All right, so let me just call it this. I'll just take this, put it over here, and this just remove group by. Over here I'll just say this. So here I'm just putting data frame name and the column name dot replace, and in that I'll just supply dictionary or maybe array, you can say, replace, and the array which I want to supply is n, I want to say 0, and y I want to say 1, right? So I'll do the same thing for reality as well. Reality is something has to do with property. Okay, and then I'll just try to see this information. Okay, I'll just try to, this will give us the idea if that is done correctly or not. Looks like it is done correctly, isn't it? See, n had 202924, here we have 0202924. Okay, so looks like it is done correctly. Now when I come back over here and I simply execute this, let's just see what happens. Now if you see, we got those two variables as well over here. You see, flag own car and flag reality. Alright, so now let's just, the next thing is, you can see that they don't have very good correlation with the target variable. So what we're gonna do is we're gonna just drop them off. Okay, so I will just say app flag removed equals to app missing removed. Out of that, labels, come on, just bear with this. Oh god, why I did this? Labels, I'll just take a list of all these things, flag variables. Alright, so here we have one issue, and that issue is we don't require the target variables. So what I'll do is I'll just take this, simply come back over here, let me just try if this works. We don't require these many things over here, this. All right, and let's just call it in place equals to true. Axis equals to 1, and at the end I'll just print its shape. What is this that I'm doing? This is absolutely rubbish. Here I just need to say drop. Now let's just see what's the problem. Alright, so we are done with removing these columns as well. So now you can see in this particular table we are left with 65 columns. Alright, so let's next see what other columns are there that we can remove. Let's see that. We are done with removing the flag columns. Next thing, what is it that we have? Let's just have a look on that, and I'll just say this flag removed variable underscore head, and let's just see what is that we have. Now this all looks good. Then what are the other columns that we can try to remove them? Okay, let's just see. Why does it still showing flag columns into it? That's a problem, isn't it? And let me just call it flag removed. Here I must say in place equals to true. What's gonna happen if I say this thing? Oops. None type object has no attribute. Again, this is pathetic. Let me just fix it. There's nothing much. I just need to come back over here and do this. Just repeat this thing since beginning. I have already done this thing, so it won't take longer. Okay. From here, missing removed. Just right from here, I need to start. Oops, this is giving the error. Record. Okay. This should get executed. Done. Done. And done. Then over here, it had the issue. What is the issue over here? It is simply saying this removed, but when we do this, here we are seeing those flag columns. Do we have that? Yes, we have that. Flag document 5. Ideally, this should not be available over here. Let me just have a look on this. Okay, so here we have listed only few columns, okay, that we need to remove. While we need to remove all the columns, so you remember here we had a big list for all the flag columns. We had created that, which is called flag call. This one. Let's just see this. 28 columns. So we need to remove this entire columns. Okay. So let's just come back over here, and out of this I'm going to remove this and put this. Now let's just see. Now we are left with 45 columns. Let's just have a look on this. Now if we come back over here, we don't have that flag columns. Now the next thing which we need to do is target the next variable which we want to remove. So let's just have a look on this data. There must be some column which we are not interested in. Okay, so what could be all those columns? You see, these are the negative values which we have. We would require to remove those negative values, and we will be doing that next. Alright, so here we have exit source 2 and 3. Let's just see the definition of these columns. Let's come back over here, and in this I'll just put that column name, and here it simply says normalized score from external. This is not required for us. Okay, so I'll just try to okay, so we can simply say either it is not required, or we can just check the number of missing values that we have into it. Let's just have a look at what is the proportion that it has, because this is absolutely a EDA. That's why I'm not skipping this. I am trying to keep you over here. All right, the number of missing values are not much, but let's just see if this has any value keeping into the data. Okay, so what I'll do is I'll just try to find the correlation for this again. Okay, so let me just say this variable, and then again the third one, and I want to check the correlation with target column dot car. Okay, so here instead of comma I just put the dot. So here is what we got. Let me round it up to 2 digits. So here is what we got. Now what we need to do is just plot this on a heat map. So I'm directly going to plot this heat map, and here again I would say the same thing, C map equals to cool warm, and over here I will say line width 0.5, and then next thing which I need to say is anode equals to true. All right, wonderful. There is some problem into it. Here I just need to say data. Let me just see if this works. Nope, there seem to be some more problem. What is the problem? Coordinates object has no CMap. CMap, here I need to say CMap. Here's what we got. Okay, again, like you can see, we don't have a very good correlation with target. Okay, so we are good to drop this as well. So here I will create another data frame, app score call removed equals to flag removed, and out of that the columns which I want to remove is these two, just not the target one, because that's very important one. All right, and here I will say axis equals to 1, and here I just need to say dot drop, right? Otherwise it will again not work. Okay, now let me just see what is the shape that we are coming up with. APE shape. Oh god, oh no, there is one unmatched thing, and this I need to put in over here. Why is it saying unmatched? Okay, that's not required. Now we are left with 43 columns we are left with. Now on these columns we will start our feature engineering. So now that we are done with removing the columns which were not required or not very much important because of the missing values or because of their loose relation with the target variable, right? So we are done with that particular stuff and we are left with only 43 columns. Now next thing which we will be doing is we will be jumping in feature engineering, and the first topic is gonna be missing imputation. So in that we will just see what all are the columns which are missing value where we need to impute the missing values. Okay, before we proceed further, let's just come back to this list, and here I have highlighted all those columns which we deleted. All right, so these were something which were deleted. After that, score was also deleted. I'm just trying to keep a reference of all the things which are happening over here so that it will be useful for us, you know. Now this is done. Then exit score 2 was external score 2 was also, sorry, external source 2 was also removed. We had removed that. Then we had removed these flag columns. All right, now let's see what else that we removed. Flag on reality is something which we also had removed. Okay, let me just see what all are the flag columns. So these are all the flag columns which we had removed. These were somewhere 28. All right, so these all columns were removed. Now let's just see how many we are left with over here. Are this 43? Yes, exactly, this is the number we are left with. We are left with 43 columns. All right, so here we have the reference of all the columns. Let's just jump back over here, and after removing all the required variables, let's try to have a look once again. So now this is our latest data which we will be using throughout this. Okay, so app score call removed. Let's again see the number of missing values. What is the status now, right? So for that, what we're gonna do is again same thing, and I'll say sort values, and let's just run this. So here again we are getting the absolute number over here. These are the columns which we are left with. Now we're gonna treat the missing values in these columns. Let's see how we're gonna do that. Okay, so let's try to convert this into percentage, and you already know how to do that. So we will just, you know, we are just going to divide it with the total number of records which we have in the data frame, which is going to look like this. Now after dividing, this is the percentage which we get. All right, so here starting from here we have the missing values. So if you see day last phone change, that has 0.0003. so let me just show you. Here I have the reference. Here we have just one missing value, so we can live with that. Let's forget about that day last first change, and we will hardly be using this particular column in our analysis. Now coming to this count family members, so let's just try to see this one. Okay, I will just come into this segment, and here I'm just going to use the table name first of all. So table name is app score, column removed dot, the column which we're gonna look into is this count family member. I'm just trying to see what all are the values that we have inside it. Okay, so here I will just say group by, and let's just say this, and size is something which will give you the count over here. Okay, so here it's the numeric value that we have over here. So most of the families have just one member, no, two member into that. So let's try to find the mode of it. What is the mode? Okay, so I will just use app score dot, we're gonna find mode of it. So what is the mode that we're gonna get over here? All right, so I just made a mistake here. I just need to put the column name as well, otherwise it will work on the whole column. So here we are getting 2. So let's just fill the missing with this particular information. All right, so how can you do that? So this column, this is the column which we want to fill, and I will say this. Here I will just say this dot fill na. It's taking some time to load. Let it load completely. Or let me just start with this. Fill na. Okay, now in this we're gonna see the parameters. What all are the parameters that it accepts? So here it's gonna take the value. What is the value that we want to use to fill the missings, right? So that's something which we're gonna use mode, but that will be used on this particular variable. So this variable dot mode. All right, and then after here we're gonna say access equals to 1. Let me just remove this. What do you think? Is this going to work? Let me just try. Okay, here is some error. It says no access named 1 for object type. All right, let me just see what is the problem over here. It says access is not required. Let's just see. It is done. And now if I see over here, I'll just say group by, and over here size. Let's just see what is it that we are getting. Okay, so here we won't be able to know what exactly is happening. So what we're gonna do is I'll just say is null, and then over here I'll say sum. Still there are 2 missing values. So one thing which I will do over here is I'll just say in place equals to 2. In place equals to true. Now let's just see. Now there are all the rows which are missing. Let me fix this. So here what I'll do is I'll just, first of all I just need to put this in a bracket, and then let me just remove this. This is not required. And over here, whenever you're using mode, you just need to slice that and pick the first element only. Okay, now let's just run this, and this is giving the error. So what I'll do, I'll reset the data, come back over here, and let's run this, and here we go. Now we have 0 missing values for this particular variable. Let's have a look at the next column that we have is occupation type. I'm taking it one by one so that first I'm targeting the categorical variables. Okay, so here let's just say occupation type. If you see here, you have 31% of missing values into it. Now there are two ways. First of all, let's just check what all are the values that we have in this particular column. Okay, let's just try to figure that out. Okay, so how can you figure that out? So same thing we're gonna do over here is, let's just say group by, and inside the bracket, instead of count family members, I will just put occupation type, and this will just give us the size for each of the item. Okay, so if you see over here, we have, you know, accountants, cleaning staff, etc., etc., all these things we have over here, right? So like you can see, which is the, let me try to sort this, sort values. All right, now here we go. So laborers are someone, laborers is the category which has maximum number of records. Now there are two ways. I mean, there are two ways to fill the missing value in this particular column. Either you can use laborer, this is the value which has been used most often. Either you can use this value to fill missings into this particular column, or you can use just unknown or not available, etc., into that. So if you are using not available, like you can see that it has 31% of missings, right? So there are two things which might happen. If you fill all this missing using NA, then the category, when you do the analysis, most of the categories, I mean, this category will be something where you will get most of the population, which will not make any sense, and you won't be able to conclude something. And if I feel that using laborer, then again we will get this particular category which has most of the population into it. Okay, so in this case, in my present scenario, I decide to go with filling the missings with laborers, right? So here I will just try to show you. Let's just see, the mode will be the same thing. Group by is not required, sorry. All right, so this one is also not required. So what you see as the mode is laborers. Okay, so that's the, and now if you pick the 0th element, this is what you get. This is why we were using this slicing over there. All right, so now if you see, this is something which has been used most often. So let's just try to use the same thing to fill the missing values in this particular column. Now what I'll do is I'll just copy paste this same thing over here, right? And I'll just change the variable name. Okay, I was just trying to zoom it so that it will be visible to you, but that's okay. Now the next thing, over here and over here, we are done. Now let's just try to run this. It is done. Now let's just try to see what is the status as of now. Does it have anything missing? Is null dot sum, and let's just see, we have 0 missing values into it, no missing into it. Okay, so we are done with this as well. We are done with replacing occupation type, and we are done with replacing the family count. All right, here also we are done with replacing this count family members. Next thing which we are going to do is, let's see what is the next thing that we should target. Okay, so amount good price, that's something it's a numeric variable, we will see that. Name type suit, let's try to figure that this variable out. I'll just try to copy this from here, and I will just go back and try to, so you're gonna bear with me, right? So because I'm trying to make this as an absolute beginner, and like you can see here, I'm exploring the things, making mistake and correcting the things. This is how we learn. That's why it is going slow, and you please be with this, don't get bored, right? All right, so here let's just start app score, and inside that I'm just going to see the missing value status, which is null, and at the end I'm going to see size of this. Let's just see what happens. Oh, it's a disaster, man. size is not something which is gonna work over here. How can you do this mistake? Okay, so we have these many missing values into it. Okay, how we gonna replace this? Again, we will try to find the mode of this particular thing. Okay, so let me just say mode, and let's see what is it that we get. We are getting unaccompanied. Unaccompanied is the category where most of the peoples are falling. Okay, let me show you what all are other categories that we have into it. Group by, and inside that I'm just going to say size, and over here let me just try to I mean, this is pretty much clear over here. If you want, you can sort this as well, right? So unaccompanied are something where most of the people are available. Okay, now we can use the same one to fill the missing values. Let's just try to do the same. Okay, I'll just do undo, and then this equals to this dot fill NA, and inside that I'm going to again use this mode, and after that here I'll just pick the 0th element. Okay, and let me just copy this. Okay, now let's just see is null at the end. Let's just try to sum. Okay, so there are 0 element available with missing values. Okay, now this variable is also done. After this, what is it that we should see? Next one we gonna look at is, let's just come back over here. Let's see the amount annuity, right? Amount annuity is something which we will be looking at. Let's just see this. Amount annuity, let's come back over here, and let's just try to find the app score call removed. Inside that I'm just going to put this, and can we check the type of this particular thing like this? It's a series. All right, D type. Let me just try D type. D type, is that going to work? This numpy D type float 64 object is not callable. That's okay, but ultimately we got to know that it's a float variable. Okay, so that means it would have the decimal values, which means apparently it's a numeric value, right? So how can we analyze what sort of value that we should use to impute this? Okay, so let's try to call describe on this describe function, and let's see the information. What is it that we get over here? This will give us statistics, descriptive statistics of it. Describe it auto completed many things, and here we go. So like you can see, it has minimum value 1615, maximum value 258,000, right? Mean is 27,000, and the median, this is median. So median is 24,903. So if you see, median and mean are quite close, right? Though it's not exactly same, but it's quite close. So it seems like data is not highly imbalanced, right? So we can try to use mean value to fill the missings, right? So we can use the mean value. Let's just try to do this. Okay, I'm just going to, I'll fill the missing value in amount annuity using mean. So let's just say this dot fill in, oops, please bear with me, let me just remove this, and here I will say dot fill NA, and inside that I'm going to do this dot mean, and what do you think, is this going to work? Looks like is null dot sum, and let's just hit run. Ooh, it just worked, right? It is gone. Bravo, it's like champion thing, isn't it? Now we are done with removing the missing values in amount annuity as well, right? Now after that, what is the next thing that we have to look into? So we are done with amount annuity, we are done with this, we are done with this. Next thing which we have is, you know, def 60 count. These variables we want most likely we will not be using an R analysis. If you wish to use this, then you can either ignore this, because you see the missing values are too low, not much, right? So you can either ignore that, or if you want, you can just fill that. I will not be using these variables in my analysis, because this is, let me show you the definition of this particular column. Okay, let me take you to the description part, and over here I will just find the column description. So here it is simply saying how many observations of client social surrounding defaulted on 60 days. So this will basically give you the idea whether the area client is coming from, it's that negative or positive kind of area. So here we will see if this is required at the analysis part. We will come back and replace this. As of now, I am not going to replace missing values or treat the missing values in this all columns. Okay, name suit type we have already done, right? Name suit type, it's something which we already did, right? Name suit type is done. Then comes this variable. Okay, so what is this variable? Let's just try to understand this particular variable. Amount request credit bureau quarter. Let's just see what comes over here. So it says amount request credit bureau quarter. This is number of inquiries to credit bureau about the client 3 months before application. Okay, so what happens is, whenever you are applying for any credit product, be it loan, mortgages or credit card, it is, see, the companies check your scores, right, in the bureau. In India it is CIBIL, somewhere it depends on the country to country. In India it is mostly used, what mostly used is CIBIL. Okay, so that is changed, and this column is showing that particular information only, right? So here it simply says that how many times the CIBIL score has been changed for has been checked for a particular customer. Okay, for a particular customer whom we are going to study or whatever it is. Okay, that's what it is saying, nothing else. So here if you see, it is hourly, daily, weekly, monthly, yearly and quarterly, right? So this is how records has been captured over here. Okay, so it will simply tell you in 1 year how many times his CIBIL score has been checked. In a week, how many times it has been checked. So it starts from the granular level, so it is checking, it is giving you the information for hour basis also, right? So whatever numbers you get over here, that will be part of this, that will be part of this, that will be part of this also, that will be part of quarter also, or that will be part of year also, right? So let's try to see the absolute number, how many records that we are getting. You will see, like you can see, the numbers are absolutely constant, missing numbers are absolutely constant. That means whatever missing values are available, that is in hourly basis, and apparently that is coming in all the other frequencies. So anyway, we will just try to see how we can fix this. So let's just check out whether what is the data type of this particular column. Okay, let me just pick this one. All right, I will just come back over here, and here I'll just say app score and just write this, and over here I'll just try to check D type. So here again, this is also a float data type. All right, so though it is giving error, but ultimately it is solving our problem, so don't worry about it. So okay, so I don't need to use those parentheses, and after that I'm getting exact data type. Okay, so this is done. Now let's just try to, so because this is the numeric value or continuous variable, so here finding mode will not make much sense, right? So let's just describe it. Let's just see how does it looks like. I'm just trying to find again the spelling error, because you know why this is happening. I use the tab key also, and at the same time I type it manually as well. So if you see over here what is happening, mean is 0.006 and the median is absolutely 0. Okay, so median is absolutely 0. Let's just see what sort of values that we have. Look, this is a score, so it cannot be in decimals, right? It should not ideally be in decimals. Okay, let me just try to see the values, how the values are looking like. Okay, it is 0.0. Do you think that it will make sense to have a look at unique values? What are the unique values that we have? Alright, so if you see, the unique values which we have are whole numbers. So if you use mean over here, that will not make sense. So ideally we should go with mode, which is 0, right? So we can just impute the missing values into it with 0. So because here I showed you there are many this kind of variables available over here, right? So we will try to impute the missing value in all of these variables in one go. For that, what is it that we first need is we require the list of all these variables. So how can we get the list of all these variables? First, let's just try to create the list of all these variables. So here I would say amount rec call equals to blank for call in app score call removed dot columns. So here I am taking the list of all the columns available in this table, and I will say if call dot starts with, and inside that I will put this standard value. Okay, because only last part is changing to hour, week or something like that. Okay, start with this, then I want it to append amount rec call dot append, and inside that I will put call, and we will just see how does it looks like. Amount, let's just see, here we go. Now we got all these columns. Once we got all these columns, next thing which we need to do is impute the missing values into it. How can we do that? We decided to impute the missing value into it using median. Okay, so let's just start the same way. Here we're gonna say for call in this, all right, and then next thing which we're gonna do is I'll just come back over here and I'll copy paste the string from here. I'll come down right over here and I'll put this instead of this column name. What I will do is I'll just put call, so that it will use a particular column whichever comes in the loop, and over here also, and instead of mean I'm going to say median. All right, now let's just run this. It is done. Now let's just try to find the missing values for all these columns. Okay, so what I'll do is I'll just say app, let me just see if this works. Okay, call and is null dot sum, 0 missing values. We don't have any missing values in all these things. Okay, let me just see if this, if I say it labels, no, that's not required over here. Okay, anyway, this is just showing you that there are 0 missing values, so it's just fine. We can live with this. Or if you want, what I can do is for your level of satisfaction, I'm just going to throw this dot sort values, and let's just go down. Here we go. Where is that amount columns? Here those are. Here are those columns. Like you can see, all of the values are replaced. So like you saw how we can find these columns with similar name, make a list of that, and then do the replacement into that. So I think we are done with replacing the values in all the required columns. Like we replace the missing values in this column, and in this column we are going to live with this one. This we are going to live with these columns as missing, having missing values. We will see how to take this particular column moving forward while we are doing the analysis. So this is it in this one, and next we will start with looking at the values, how the values are looking like, where we need to make some changes in the values, negative, positive, and all those things. Now next thing which we're gonna see is how to modify the values which are available in data. Why is that required and all? Before we move forward, you remember in the previous video I said this particular column, where is that? Amount, goods, price, right? So before we move forward, let's just analyze this so that we will not have to come back to this particular column again. Okay, goods, price, let's just understand its definition first. All right, so let's just see where here this is not required. Let's just delete this, and over here what we're gonna do is just look at the definition of this particular column. I'll come over here. Let's just find this. Here it says, for consumer loans, it is the price of the goods for which the loan is given. All right, so let's say if the customer wants to buy a car, okay, and for that he is applying for the loan, right? So the whatever loan will be given to him, that will be populated into this particular variable. So it seems like a critical variable. So let's just go ahead and try to treat this first. Okay, so what I'll do is just the same thing over here. Let's just have a look on this variable. First of all, app score, and then this variable. Let's just see the total number of missing values. Let's just take a sum of that. Amount, good, price. Okay, removed, app score column removed. Here this spelling is not correct. Okay, 278 records are there which are having missing value. This is not too high, but still let's just try to treat this. Okay, let me just describe this particular variable. And here we got this. Okay, so this is not pretty clear what is the description of it. So what I'll do is, instead you can use ag, and in here you can supply the list of functions, let's say mean, max, median. Here is what we got. So median is 450,000, mean is 40,000, right? And median is 450,000. Let's see how does its mean looks like. This is minimum, and now we are going to find the mean value, means which is the average thing, right? Let me just try to find that as well. Not min, it's mean. So the mean value is 538,000. This look quite huge, right? 450,000. Okay, 450,000, 538,000. So I feel that we can still use the median, because median looks more relevant. This data again seems like having the outliers, right? It seems like it has outlier, because you see this is the value which is looking like maximum one. That's something which we will see. As of now, median looks more relevant to use to fill the missing values, because see, this is just 450,000, and the mean, which is average, you are getting 538,000. When you say 450,000, that means half of the records, half of the customers, the total records which we have in data, half of the customers have goods price as 450,000. But if you impute the missing value with 538,000, the data will be imbalanced, right? So that's why here, to fill the missing values, we will not use mean, but instead we will use the median. Okay, let me just try this. Okay, and then after this I'll just take this, fill NA, inside this, and here I will say median. All right, so looks like it is done, and let's just see what is the missing value that we have. Next, sum, 0 missing values. Now let's just try to take head of it. Let's just go ahead and see how the data looks like. Now you see, these are the negative values. We would require to convert them to positive, so that when we are doing the aggregation, that doesn't give us something unwanted result. Okay, So you see this column is also not required. If you want, you can drop this, but I'm just keeping this because look, I'm not going to build a model on this. Here I'm just going to do certain analysis. So instead of dropping the columns, even if I keep that, I will not use them in analysis, right? That's how I'm going to do this. Amount credit is one variable. Let me just see what is the missing percentage into that. Amount credit. Okay, it is taking time to find that over here. Instead, what I can do is I'll just find it right over here, and inside that I'll just put amount credit, and let me just see if this has any missing value. I'll tell you why I'm focusing on this. This doesn't have any missing value. That's fantastic. Okay. All right, so because see this amount credit, let me show you the meaning of this particular column, right? This is important thing. So amount goods price is something which is the price of particular product for which customer is applying, and now amount credit is something how much is the amount which has been given to the customer, right? So both of these two columns are important, right? For example, if you see let's say you want to buy a car of 10 lakh Indian currency rupee, okay, but your eligibility shows that you can only take 8 lakh, right? So amount good price would have the value 10 lakh, but here in amount credit you would have 8 lakh populated. So this is the difference over here. All right, so we are done with that. Now next thing which we're gonna do is we gonna convert these negative values, where we have those negative values, like we had certain columns called days, like you can see these columns. Okay, you see these columns: days ID published, days registration, days employed, days birth, right? So all these columns we are going to convert that from positive to negative. So again the same thing which we're gonna do, that is finding all the columns which is starting with days. Days call equals to this, and after this I will say for call in app score dot columns if call dot starts with days, then days underscore call dot append, and inside that I will say call. After that what I want to say is days call. I want to see the list of columns. Okay, so here is what we got. Now to convert the value from negative to positive, you can use the formula called absolute. So let me show you how to use that. Okay, app score, and here I'm going to put the column name, let's say days birth. Days birth means it is simply showing your age in days, all right, not in years. App score call removed, and here I would say absolute, and inside that I just need to put this particular value. That's it. So this is what I'm going to do using the for loop, not in the simple way. Okay, so this will just make it absolute. Let me just try to create a for loop where I would say for call in days call and here is what, and instead of this I only need to do this thing. Here I will just say call, and over here also I will just say call. Okay, now let's just see, this gives the error. Let's just investigate the error. Here I am just missing one square bracket. This is done. Now let's just see the head of this data. Oops, the incorrect spelling. All right, so here we are. Now let's just try to check the value in days column. Looks like it is converted. It's just I'm not able to locate that because I'm scrolling too fast. Now here we are, right? So days birth, these all were negative previously, now these are converted in terms of positive. So this is how you can convert the values wherever needed. As of now, let's just be with this. This is what we require. Okay, now next in the next thing which we're gonna do is we will look for the outliers, and then we will treat them, and then we will do the binning of the variables. So now here in this video, what we're gonna do is we're gonna study the remaining variables whatever we have, and then we gonna do the binning of the data, right? So what binning is, right? So let me just try to help you understand. Let's say somewhere it has been given age, right? So for example, let's say 20 years, 34 years, 25 years, then 78 years. This is how mostly the ages are given. Okay, so what we do is when we are doing the analysis, we create intervals for this. For example, for this, let me just sort this data for first of all, and when we sort this, so for this we can say age between 20 to 30. All right, so this is what the age group, right? Then for this age will also come in the same group. Okay, then we can say, let's say 30 to, let's say 50, and this 34 years comes in this group. Okay, and so on. So this kind of intervals which we create, that's what I'm referring over here as binning. I just hope you understand it, right? So to do the binning, it is very important that we have our overall picture of the numbers which we have. Otherwise we will end up making the bins which which are not much useful. So for that we will look at the outliers as well, or we would look at the density of the data, where the data is mostly dense, right? So let's start with that. For that, first thing first which we require to do is find out the variables where binning is required. Okay, so let's just have a look on the variables. Binning would mostly be required. By now you would have understood here what we did was continuous variable. Okay, so binning is mostly required for the continuous variable. Okay, so let's just figure out what are the variables where we might require the binning. Okay, so first of all, let me just see the data type for the variables which are available. Okay, first let's just take this. Okay, first let's just see how many columns are there. Before that we proceed, so we are left with 43 columns. Okay, that's cool. Now the next thing, we need to see the data type for each of the columns, so that you can check using info, and here we go. When you see this, wherever you see float, that means again that's a continuous variable. Int is also the same thing. Int could be both of the things, it's categorical or the continuous. Okay, now over here you see object, that's something which is a character variable. That will be a character variable. For example, if you see code gender would be having the value like male, female, etc. So that's why I'm saying it is going to, that's why it shows that it's an object variable. So our main focus here would be on float variables, something, let's say these variables. Okay, this set of variables, or maybe the amount variables which we saw previously. Okay, you see amount credit, amount annuity, these all variables. So our focus is going to be on these kind of variables. Let's just try to have a look and understand the data, because here we already have seen the overall information. We will also try to see the number of unique values and what is the number of unique values each of the columns has, and then let's just sort this. So this will give us the understanding whether the variable is discrete variable or the continuous variable. Discrete, when I say, means classification variable or categorical variable, which generally stores the flags like 0, 1, or maybe 1, 2, 3, 4, something like that. Okay, so those kind of variables we are just going to try to figure it out over here. Live reason not working, this has only two types of value, which would be generally 0 or 1. So for sure this is not a continuous variable. This also doesn't seem like a continuous variable, where it might have the value like some in decimals or some value where we require to perform the calculation. Def 30 count social area circle, again this is also not the one which we may require to do the binning and all. So what I feel like over here is the variables which are having unique values, let's say 33, this one, or OBS 30 cent social circle. Let's just see what sort of values does this particular variable have. So here I will say app score, and into this I'm just putting this variable, and let's just see unique, and let's just see what is the value that we are getting. Just see, these are also the content I mean the variables which have value like 1 2 3 4 5 6 7 8 9 10. So that's all right. I don't think here also we require to perform any kind of binning. Okay, so this is how you can study the variables where the binning is required. What I feel is, starting from here, this all would require the binning. Like you can see here, it clearly says amount, goods price, amount, income total. This is some this all are float. Okay, days last phone change, how many days has it been when the phone number was changed. So of course it will not be a classification thing. It would never say that one, or either 1 or 2, either 0 or 1, something like that. It will give you the absolute number of days. Okay, so these sort of variables I feel we require to look into. Of course not this one, this is the ID variable, we don't require to look into these variables. So these are the one which require our attention, which we need to have a look into this, right? So amount, good price, amount, income total, last phone change, credit, amount credit, days ID publish, days employed, day amount annuity, days registration, days birth. Let me just copy this and put it in a separate file over here, so that we will use it as a reference whenever we need. Here I'm just keeping this, we don't require these values, so you can just ignore them. Okay, now over here what you see is this 1 2 3 4 5 6 7 8 9 variables we have over here. All right, so out of this we will see not all the variables we require to do the binning on. We will pick wherever it is needed. All right, so let's just go ahead and try to evaluate the variables. Okay, so here what I will do is, like, you have understood the data, right? Or just looking at this particular thing, if you want to study it more, here is a sample. You can just export it in Excel and you can have a better view of it. So I think it is pretty clear, we can go ahead, right? So let's just start with the first variable, which is amount, good price. Do we have it? Yes, here is what we have. Let me just say app score, and in here this is what I'm going to say, app score column removed, and then describe, oh god, the okay. All right, so like you can see, this is again not giving us the correct picture, because you know correct value as values as per the expectation. So what I'm going to do is, let me just try to do this aggregation, and over here I'll just say min, max, and then median. All right, let's just see. This is what we are getting. Okay, so like you can see, median is 450,000 and maximum value is this, and the minimum value is this, right? And so half of the population is below 450,000. Then how come it could be the maximum value? This is too high, isn't it? Certainly this have some outlier. Let's try to, you know, plot this sns.kde, and on this I will use this particular data right over here, comma x-axis equals to, I will use this variable. Okay, let's just say here data. Let's just see how does it looks like, if it's a skewed data or what. Why I'm studying this is because, you know, we require to make the binnings on this, so we just need to be sure what is the range that we should start with. All right, so that's why I'm just trying to have a look into it. So here, like you can see, the data is right skewed, right? You can see it has a long tail at right hand side. So this has certainly uncertainty. I'm not sure if uncertainty will be a good word. Let me just try to create a box plot out of it. SNS dot box plot, and on this again I will try the same thing right from here over here. So if you see over here, all right, so this is, it's showing the values like this. Let me try this. Okay, SNS dot plt dot x scale, and here if I use log, how is that going to look like? No, this is not making much sense. Let's just see the quantiles. What sort of quantiles does it have? So I will just say app score, and in that this is the variable I'm going to take, this variable, and over here on this I will just use the quantiles. I've created a separate video for this quantile thing. If you want, you can just give a look, have a watch on that. Okay, and then over here I'll just put some quantiles. Let's say 10th quantile, 20th quantile, 0.2, 0.3, and then 0.4, 0.5, 0.6, 0.7, 1, 2, 3, 4, 5, 6, 7, 0.8, and then oops, I make a mistake, 0.9. I made a mistake, rather I should say. And let's just have a look on this data. What is the error that we are getting over here? Percentiles should be all in the interval of 0 to 1. So here I have used, somewhere there is something wrong. 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, and here is the problem. Alright, so now here you can see the 10th percentile of the data is staying on this part. So in the 9th percentile the data is looking quite huge. So if you see, the rest of the time it looks like distributed symmetrically, but over here if you see, this has the variance, huge variance. Here it says 1 million. Here till this point, till 80th percentile, we have the data in thousands. Over here it is changing in millions. So let's just try to see the 99th percentile, 0.99. Okay, so we have the differences. The measure value which we have is at the end, which is this, right? So over here what we require to do is, the maximum value which we had was, the maximum value which we had got was 404.05 million. So this is absolutely a outlier, because you see till 99th percentile also we are not getting that value, right? So here we can conclude that the most of the values are below 1 million, right? Below 1 million. Okay, so this is how we will, so while creating the binning, creating the bins, we will take care of this thing. Now this will help us in binning the data. Let me just try to delete this over here from here, and I will create the bins for this particular thing. Okay, so here is what we call it. I'll give it a name as range, and over here I will just use this. Here is a function which is called pd.cut, and inside that what you can do is supply the data on which you want to perform the binning, and then you supply the bin, and then you supply the labels. Labels will be, okay, so here, come back over here. So labels will be this kind of value. What is it that you want to say? And then for in bins we will have to supply what is the value that we want to consider. So to this you can also say that below 30, right? So below 30 is your label, and the value which you are going to consider in this interval will be bins. Okay, so let's just try to create these two lists over here. Bins equals to, here I will just say, let's just start from 0. And what is the minimum value that we have? Though we can start from 0, but I just wanted to have a look at the minimum value. So it's safe to start from 0. We will say 0 to 40,000, because below 40,000 we don't have anything. So we'll just say 0 to 50,000. Okay, 0, then we're gonna say 50,000. This is 180,000, right? So let's just say 0 to 50,000, and then 50 to 100,000, then 100 to 150,000, then 200, then what else? Then we can say, 250,000, then 300,000. All right, so this is how we can make multiple intervals. Let me just try to increase this for the 300,000, and after that I'll just make it 400,000, then 500,000. I know I'm not following the same pattern from there. Okay, 500,000, and then 600,000, 700,000, 800,000, 900,000, 900,000, and then the last value which we have is, let's just say we will require to give the value something greater than this. So I'll just copy this itself, okay, and come over here. Let's just put this thing over here. Okay, now all these things has to be in thousands. Let me just put it over here. If you want, you can skip this part because it's nothing. I'm just repeating the same thing. Okay, $100,000 and 50,000. Okay, now we need to create the, still these are looking so many bins, right? So what we can do is 50,000. Here we can just remove the 50,000. Let's just keep it 100,000. Then let's just remove this 200,000, 300,000. I'll keep 400,000, 500,000, 600,000. Right, so this is still better. Okay, now let's just create the ranges. I'll just say it ranges. So the first range is 0 to 100k, then 100k to 200k, and so on. I will just be repeating. So I'll pause the video and then I'll complete. Alright, so like you can see over here, I'm done with creating these ranges. So if you see, this particular list has somewhere 11 values stored into it, and this particular one has 10 values only stored into it. So ideally this particular one should have less number of elements, one less than the number of elements which you have into this one. Okay, so that's what it is. Now let's just take this and put it right over here, and let's just see if this works. Okay, let me just hit enter. Okay, it just gave the error. What is the error? Amount good price range. Where is the amount good price range? All right, so here I just need to give, I don't need to give this. Now what is the error? Got an unexpected keyword, which is labels. So it's not labels. Is it label? Let me just see the parameters. From here what you can see is labels. Here is this. Okay, alright, so here it's bins. Now looks like it is done. Now let's just see the count, how it is looking like. Okay, so for that, like you would have understood by now, we can use group by, and over here this we need to put in parentheses, and over here we're gonna say size. All right, so here is what we got. So below 100,000 only 8,709 people are there. So this is the range where most of the population are. Okay, like you can see just right over here. You see over here. Now then this range comes, and above 900,000 very few people are there. 41,000 people are in above 900,000. Okay, all right, looks good. So this is how we can do the binning for rest of the variables also. So what I'm thinking is, just to keep the video concise, I will do the binning for rest of the variables, and then you can see that in the final result. So what I'm going to do is, yeah, either I'll fast forward it, or let me just fast forward this thing. All right, everybody. So I think I'm done with binning all the required variables. So let me just give you a list of variables which I have for which I have done the binning. So these are the variables for which I have done the binning. You see these 6 variables which I have for which I have done the binning, right? So I'll just show you a summary of all these variables, how these variables look like, but not in this. In the next one, when we start with analysis, I'll just show you a glimpse of that. Now that we are done with preparing the data for our further analysis, where we saw how to do the feature engineering, feature selection, missing imputation, binning, and all those things, now it's time to start with the data analysis. All right, so what are the main concept which we have behind the data analysis? That's the first thing which we gotta think of it. All right, so to start with any sort of data analysis, first of all we need to understand what the data is, right, and what is the problem statement. All right, let me give you a walkthrough one by one. So here we know that our data is about loan defaulters, right? So we have the data where customers has taken the loan, and we have the detail who out of all those customers defaulted the payment, or who out of all those customers paid the payment, made the payment on time. So to understand that, in this loan default data we have one variable called target, which has the value 0 and 1, where 0 indicates to no default and 1 indicates to default. Now this is the data. To do the EDA, exploratory data analysis, or any sort of analysis, it is important that we have a view. What is it that we want to get out of it? So that's called the problem statement. Okay, so there could be two situations: one when we already know the problem statement, the other one when we don't know the problem statement. As of now, we are going to have a look from this perspective where we know the problem statement. So what the problem statement is: for example, given this data, the bank wants to understand what sort of customers should the bank target who will be non-defaulter, what sort of rate of interest that they can provide to those kind of customers, and the customers will not default, and many more. So here we will try to cover as much as we can. So to start with this, first of all, what we need to see is, out of whatever we have available, we will have a look at non-defaulter customers. We will also see the defaulted customers as well simultaneously, but let's talk about non-defaulters. We will pick out the non-defaulters and we will try to analyze their features. What are the features that they have because of which they are turning to be non-defaulter? For example, what is their profile, whether they are employed, businessman, etc. What is their education? All right, what is their marital status, what is their residence? Basis on this we will try to establish a pattern, right, and then we will conclude that this segment of the customer can turn out to be non-defaulter. All right, so I just hope that this gives you a bit of understanding. Let's jump back to the Jupyter notebook, and here we know that we have this particular data frame where we have all these columns. Let's just check out the data type for all the columns which we have, right? So we have altogether 49 columns, right, out of which we can see we have some float variable, object, and some category variables. So category variables are those where we had created the binnings, right? Then float are those continuous variables. You can also consider float and int as numerical variables or continuous variables. Object we will consider as categorical variables. All right, so this looks hazy for any analysis because we are talking about the analysis, right? So let's just take the count of all the variables by the data type, right? So let's say data type. All right, let's say data type dot value counts, and what is it that we are getting? So here we got the result, right? So like you can see here we have 18 float variables, 15 int variables, so altogether 33 approximately 15 to the 30 and 33 variables we have numeric, and 10, 11, 12, 13, 14, 15, 16 variables we have as character. So let's just focus on object variable as of now. So let's just pick out the object variables. How can we get that? All right, so let's just say app score removed dot select data types, and in this we have a function called, we have a parameter called include, right? So you can use the include parameter, and in that what you can do is you can say object. Let's just see if that works. Okay, I'll just take top 5, I mean head. All right, so like you can see here, here's what we are getting, right? So here what you have is just those columns where the data type is equals to object, means the categorical variables. All right, so now what we're gonna do is we're gonna just get the list of the columns. Okay, columns, and let's just run this. So here we go. Now let's just store this in a variable called obj var. Okay, now, and once that is done, here we go. All right, so we got all those variables which are categorical in nature. Now let's just start with doing our analysis with this particular variable where name contract type. So name contract type, what is name contract type? Let's try to figure this out. Okay, so this is our table, and first of all you want to understand what sort of data that we have in this particular variable. Okay, so let me just put this over here, and here I will say size dot size. Oops, it just gave me error. Let me just see what is the error. Okay, the column name is incorrect. Here we go. Right, so we have two kind of value, cash loans and revolving loans. Let's see the proportion of this value. What is the proportion of this value? Okay, so we're gonna say sns dot count plot, and in that we will be producing data equals to app score removed x-axis. We're gonna put this particular variable, and in hue we're gonna put target variable. So you all know that if you are following this series, you know that in the target variable we have value 0 and 1. 0 means no default, 1 means default. Let's just see what is the output that we get. Oh, we got it. Okay, so here approximately 250,000 customers. There are two types of loan which has been given to the customer. One is cash loan, the other one is revolving loans. All right, so in cash loan approximately somewhere 250,000 customers, more than 250,000 customers are non-defaulter, which is quite good signal, right? And if you see somewhere this is 50,000, this could be somewhere 21,000. all right, so this is approximately 21,000 customers who has done the default, who have defaulted. Okay, now let's just try to get the percentage of it. If we can get the percentage, how do we get the percentage of it? Okay, that's the problem statement. So here I will just try to calculate the percentage, what percentage of the customers has defaulted in cash loan and same in revolving. Okay, so let me just try. So what I'm going to do is I will just say app score this, and let's just say group by, and into this I'm going to say, let's just say this variable name and the target variable, target. All right, dot, what we can say is mean. Let's just try mean. What is it that we are getting? Okay, let me do this. Let me take this out of it and just put over here, because here what I want to do is I just want to figure out of these two loan types, cash loan and revolving, how many, what percentage of the customers are defaulter and who are non-defaulters. Okay, so that's the problem statement. Now let me just try to do this, and let's just see what happens. Oh, it just gave the error. Name, contract type, and target. Let me just see if I can just enclose this. Yeah, it looks like working. Okay, now here one more thing as I'm going to do, and that's over here. Now it has done the commitment, and now he is saying that once I am done with the commitment, I don't listen to anyone. Okay, I'm just speaking rubbish. Just don't focus on that. Okay, let me just pause the here. Sorry, so I fixed the issue while the video was paused, but I'll tell you the what exactly the problem was. There wasn't any problem. It's just I should have to use this variable in group by instead of target. Okay, because I need to find defaulters by the loan type, right? So after doing this is what I get. Right now I need to convert this into in terms of percentage. So this is average. So when I would say just put some mind and try to understand how average I'm trying to convert into the percentage, you will get the clarity. Okay, so this is what over here. Now here I'm just going to use one parameter, let's say called as index. Let me just see if as index equals to false. All right, and now let me run this. You see the difference? Okay, so this is what we got. Now let me create another variable called pct, and here what I'll do is I'll say data pct, and here I'm going to take the variable target multiplied by 100. Okay, now let's just see what happens. Okay, so here we got the data in terms of percentage. All right, here is what we have in terms of percentage. Now let's just try to draw a bar plot basis on this. Okay, here I'm just going to say sns dot bar plot, and into that data will be app score call removed, and on x-axis I will be plotting this part, and on y-axis I will be plotting pct. And let's just see what is it that we're gonna get. What we get is error. pct could not be interpreted into the input. Yes, because the input data which I have used is incorrect. Now here is what we got. All right, bravo, we got it right. So the customers who has taken cash loans, out of that 8%, 8 point some percentage of the customers have defaulted, and the customers who has taken revolving loan, out of that somewhere 5%, 5.5% of the customers have defaulted, right? So you see cash loan has more defaulters. However, if you see the number of customers who has taken cash loan is too high compared to revolving loan, so still we can say that the people who are taking the cash loan are less likely to be defaulter, right? Because if you calculate the proportion, you will get that the cash loan has less defaulters. Now this was the two separate plot. I will quickly show you how can we draw it quickly. So first of all, you will have to calculate this value, right? So let's say we already have this value calculated. So what I'm going to do is I'll just take this variable from here and put it just right over here. Okay, and this data I will take this one just right from here, and I'll just try to plot both of these two graphs side by side. Okay, and here I'm just going to say, let's say plt dot figure fixed size. Okay, and let's call it 10 by 5, and here I have to say plt dot subplot, and into here I'm going to say that I would like to have one row, two charts, right? And this is the first chart which I'm trying to prepare, chart or graph, and this is the second one. Okay, now let's just plot this. and you see, like you can see, both of these two things are plotted side by side. It gives you a very clear picture. Now this is just one categorical variable or object column, right? We have many more, right? So how many columns that we have all in together in total? Let's just check. Length. So we have 10 columns which are of object data type, wherein we just checked it for this particular column. I would suggest you to do the same thing for all these columns in context of target variable, right? And let me know your observation into the comment section. What is it that you observe? What is it that you conclude? For example, here what we conclude is most of the customers who have taken most of the customers have taken cash loan, right? Cash loan. And then customers who have taken cash loans are less likely to default. This is our conclusion basis on this analysis, right? This is what we conclude. Same way, I want you to do the analysis for all these variables and write down your conclusion over here and in a notepad and put that into the comment section. Otherwise, I'll just cover all these variables. And not only I will do the analysis, I will also try to show you how you can do this thing automatically. Means every time you will not have to go and change this column name. Everything will be done automatically. All right. Now have a look and create the similar plot for all of these variables, and then further do the analysis and take note of all these things. You remember previously I said that you do this thing by yourself using this kind of statement, right? And write down the analysis in the comment section. But don't worry, whatever you have done so far, just keep that with you. And now let's start creating the similar plot for all of these things, right? So let me just start with it quickly. So what I'm gonna do is I'll just take this statement from here and I will just insert a new shell just below this, and over here what I'll do is I'll just put this over here. Now I need to run a for loop. So before we do that, what I'll do is, because here we will be using different features, right? So what I need to do is I need to take this statement as well, where we are, you know, creating the data and the percentage value of all those things, right? So that's something which I also need to consider over here when I'm going to automate this part. All right, now this is something where we are taking the mean. After that, we had created this statement as well, which is nothing but creating the percentage, converting that mean into the percentage as well. All right, so this is done. Now let's just shift it a bit, or before that let me just say for var in object underscore var. Object var is nothing but the list of all the object variables, or maybe you can say the character variables. All right, now in this var in object var, and after that what I'll do is I'll just do a shift tab. This is done. Now after this, it's not just a var, it will be I and var. This is something which I have explained in the previous videos. You can just have a look. All right, then here I'm going to say enumerate, and this I will close. And out of this list, as of now, I'm just going to work on 2 variables, right? So that's what I will write over here. Now once this is done over here, what we require to do is we need to replace this specific variable name with the name of dynamic variable, because here it will be changing. Okay, now that's what I'll do at each of the places where I had hard coded that particular variable name. Right here is the next one, and then here is the next one. Let me just do it one by one. All right, so this is done. I guess this is done. All right, now what next we need to do is we need to handle this subplot, you know, indexing. So here we're gonna say I plus 1. Okay, and then the next thing which I'm going to do over here, same way. All right, Now let's just try to, the next thing which I need to do is adjust this figure size. Okay, so in the figure size, what I'll do is I'll say, you know, what I can do is I'll just say 25 is 50, 25 by 60, let me just do it 60. Okay, and after this, in the bar plot here, I will also use the palette equals to cool warm. That is nothing but just the coloring system. Okay, so here let's just see what is the error which we are getting. Ooh, this is too high, isn't it? So here let me just make it 25 is to 25. Let me just do this and let's see what happens. Okay, still this is giving the error, and let me just see what is the error message. Here it says rectangle object has no property palette. Why is that so? Let's just see over here. It should have the palette parameter, or maybe property, whatever you say. Spelling is also correct. Why is that? Okay, now the spelling was incorrect. Now let's just see what is the error. Number must be 1. This. Okay, this is still too high. Let me just make it 20 is to 20. How does it sound? Let's just do it 20 is to 20. Again, it's giving the error num must be 1 below. Alright, so the main reason is here every time we are saying that just one row. Okay, so here we gotta say, so in total we have how many variables? 10 variables, right? So we will create 10 row, because for each of the variable we are creating 2 plots. So 10 rows, and for each of them we will have 2 plots. Okay, and now here I will just do the adjustment of the heights. So I will just say 25 is to, let's just call it 60. Okay, now let's just see what happens. Oh, this looks pretty good, isn't it? Now there is one problem. We require to have spacing between these 2 rows, right? So how can we do that? Why is that important? Let me show you. For that matter, I will just remove this limitation and let me just run this for all, and then you see what happens. It's just taking time, just bear with it, and it will give you the result. Alright, so here we got the result, right? So if you see over here the challenges which we are having, you see these names are not clear, you know, these are overlapping at each other, and most importantly, if you come down and you see here, there is nothing clear at all. Okay, so what we're gonna do is we will just say over here, what we're gonna do is we will just say plt dot subplot, and here we're gonna say rotation equals to 90 degree, and then let's just run this. Alright, so the rotation is not a property of subplot, that's rather property of x-ticks. Alright, so I will just come back over here, and here I would say x-ticks. Okay, the same thing I will do for the second plot as well over here, right? And let's just run this. Alright, so this looks pretty sorted. Okay, now just let's have a look. So if you see over here, that problem is looking sorted over here, but the only thing is, if you see here, we don't have the spacing in between, right? So for that we have another property which is called plt dot, here we can say subplots, or maybe let's just call the layout function tight layout, and inside that we're gonna put, you know, w space. Now that function name is, let's call it subplot adjust. Okay, and here we're gonna say w space equals to, let's call it 0.9. this is nothing but it is called width space, and height space I'm going to put 1. All right, now let's just run this and let's just see what happens next. All right, so here we go, right? So here we got our plots created, and all of them have the enough space in between. Okay, now the next thing which is not looking much good is these are too small in height. So what I'll try to do is, if I just make it, this is already 60, and yeah, let's just try to make it 20. And so 20 is the horizontal size, and then 60 is the vertical size, right? So let's just see how is that going to look like. All right, so this is still better than what we had previously, but still not much better, right? So what we can do is, let me just make it 25. So this is 20, but that's not looking much better, so this I'm going to make 25. Okay, all right, so it looks like we are done with creating all the graphs for all of the 10 variables. Okay, so here it looks, so to make it much clear, what I'll do is I'll just do the zooming of this. Okay, now here you can analyze the plots one by one. We will do the analysis of the plots one by one. Okay, and then we will write down our conclusion, whatever we conclude over here, right? So that's we gonna do one by one, but because this is already more than 10 minutes long, all right, so what I'll do is I'll take a pause after this video, and then we will do the analysis in the next one. I would highly encourage you, just try this thing, and in an automated way. If you have any doubt on this, just let me know into the comment section. To here, this I would have the value 0, then again I'm doing 0 plus 0 plus 1, so ultimately it will be 1. When next time it comes, this will be 1 1 1, that means it will be 3, so that means it will start from this position. Okay, so that's why I have to do it this way. This 10 means 10 rows, 2 means 2 column. Okay, 10 rows 2 columns, and then this is the indexing position. So if there is anything which is confusing you in this entire patch, just let me know into the comment section. I'll help you clear that. All right, everybody, now that we are done with creating the plots for all of the 10 character or object variables, now is the time to start doing the analysis, right? So let me just make it a little bigger. I just hope that it is clear to you. Here we are not going to get technical anymore, right? Here all of that which we are going to do is be analytical. Okay, so if you remember previously, what we had done is we had done the analysis for name contract type, which is nothing but the loan type, and here we wrote our observations. So the same thing which we're gonna do for all of the other variables, all of the remaining variables rather, I can say. Let me adjust the zooming of this thing. This is a little bigger. Okay, now here we have that, and I'll just make it a little bigger. So what we wrote for this particular variable name contract type was cash loans. Most of the customers have taken cash loan, and customers who have taken cash loans are less likely to default. That's what we observed for this particular variable. Next thing, if you see over here, code Zender. So here we are looking at the Zender. Ideally in our analysis we do not consider the Zender thing, because this might turn out to be creating the discrimination. All right, but here if you see, I'm still considering, but I would highly encourage you not to include Zender thing in your analysis. Okay, specifically if you are residing in certain countries where this is highly prohibited. Okay, for example, if you work in some if you are working in some Western countries, there if you are in some Western countries, there black and white is highly discriminated, and if your data has certain columns which has the value black and white, just avoid that. Okay, Now over here what you see is this is code gender. This is specifically saying which sort of gender. So if you see, most of the time females have taken loan, mostly females have taken loan, and they are less likely to default. So what we can say is females are safer persons to target for giving the loans, right? So if you see, male default rate is somewhere 10%, while the female default rate is below 8%. So whatever loan has been given to male, out of that 10% are defaulting, and whatever has been given to female, out of that only less than 8%, somewhere 7% female are defaulting. Rest of them are repaying the loan on means as per the expectation. So I will just write it down for code gender. What we observe is code gender. You also do the same thing, or if you have already done, then just write it down, just compare that whatever we are observing over here, right? Female population, females are safer, females are less defaulter, or let me just write default rate for females are just approximately 7%. Okay, so which is safer? Because we have taken, mostly the female population has taken the loan. Most of the loans have been taken by female, and the default rate is approximately 7%, which is safer and lesser than male. All right, so this is how we conclude. The next thing which we're gonna see is name type suit, right? So what sort of name suit type the customer have, right? So if you're confused about this, what this variable means, so you remember we downloaded the variable type also, variable description also. Let's just have a look on that. All right, so here we have the name description, variables description. Let's just see name type suit, right? Let me just find it for you, right? Name type suit, right? So it says who was accompanying client when he was applying for the loan. That means when the customer was applying for the loan, who was living with them? Okay, who was accompanying client? Okay, so unaccompanied. Most of the time when the loan was taken by the client, they were not accompanied, they were unaccompanied. Okay, so and if you see, these populations are very less, almost negligible. Okay, so either the people were unaccompanied or they were with family. Client were either with family or they were unaccompanied. So mostly when they were unaccompanied, when they took the loan. Okay, and whoever has taken loan, out of that, other B category is something which is highly defaulted. Okay, so that means what we can say is unaccompanied are taking most of the loans, and the default rate is approximately 8%. So if you see the default rate for at the time when the client was taking loan, and at that point of time they were with children, right? So those are the safest one when you see by this category, right? Name type suit. By name type suit, at the time of applying for the loan, the customers who were unaccompanied have taken most of the loans, but the customers who are living with children are less likely to default, but the number of loans which they have taken is too low. So ultimately when we come over here is the unaccompanied. So mostly whatever loan they have taken more than 200,000, somewhere 250,000 loans they have taken, right? 250,000 customers were unaccompanied at the time of taking the loan, and the default rate is somewhere say 8.5 or 9%, right? So we can still say that the unaccompanied is safer one, because that's the biggest volume, right? So what we can say, what we can write the conclusion is, for that the name type suit, if this is something which is quite obvious for you, you can watch it in XX speed. Okay, this is going to be a little longer, so you gotta be bear with this. Okay, so over here, most of the time unaccompanied accompanied people had taken most of the loans, and the default rate is approximately 8.5 or 9%. Okay, that's what the default rate is, which is still safer, which is still okay. All right, now let's move to the next variable. Next one which we have is name income type. What is the source of income they are getting? Okay, let's just have exact look at the definition of this variable, name income type. Okay, so it says client's income type, whether he is a businessman, working, or on maternity leave. So at the time when the client was applying for the loan, what was the income type? So if you see, most of the loans which has been given to the working professionals, right? And working professionals have the default rate approximately 10% or even less than that. Okay, somewhere 9% we can say. Most of the defaulters are those who are on maternity leave, but the number of loans which has been given to the people who are on maternity leave almost negligible. There is nothing at all, almost. Okay, so what we can say is working professional, giving loan to the working professional is much safer, right? So if you see, working professionals have been given most of the loans, and then followed by commercial associates, and then pensioner. Okay, so and default rate, if you see, is working professionals have the lesser default rate, then commercial associates, and then pensioner have almost no, I mean pensioners also have low default rates. So what we can see is this is a very good segment to target for the loan. Working professionals, either working professionals or commercial associates or the pensioners. Okay, so let's just write, we are doing this analysis for which variable? For income type variable. Okay, I'll just write it down. Okay, and then we can say the safest segments are working commercial associates. Segments are working commercial associates and pensioners. They are the safest one, because if you see, they are the one who are taking most of the loans, and their default rate is also low compared to this all, right? So this is a very good segment to target for giving the loan. Okay, further, if you want, you can do the bivariate analysis, and you can use the loan type on this particular variable and see what sort of loan fits well to these customers. Okay, now let's move forward, and here we are not able to recognize which sort of variable is this, right? What sort of variable is this? Okay, so what we can do is, this has the value higher education. Okay, so this is the education variable. Okay, this is the qualification variable. Let me see what exactly the variable name is. Do we have something called qualification? No. Education, yes, name education type. This is the variable name education type. I just understood what if you are not able to figure out which type of variable is this, what you can do is, in this over here, just right over here, what you can do, you can just increase this spacing and then you will get the variable name. But I'm not going to do that because as of now we are going to focus mostly on the analysis part. Okay, so here is what we were looking at. Okay, so let me just write it down over here. I know this is becoming longer video, so but because we are doing the analysis and it's very useful, right, to understand, and I'm taking it in very slow manner, right, so that it could be easy to understand and you could learn more out of it. Okay, so here if you see, the most of the loans which has been given to those customers who has secondary special education, or what is the other value which we had. Okay, so if you are struggling to see what are the values that are available in this particular variable, what you can do is you can just write a quick query over here. Let's just say app and write that variable. The variable name which we have is this. Okay, we just want to see what all are the variables that it has, right? And you can say unique values, unique. Let's just run this. It's taking time. Here is what we got: secondary or secondary special. This sort of secondary special, higher education, incomplete higher education, lower secondary, and academic degrees. These are the values which we have over here, right? So now again let me make it a little bigger. So here it is nothing but the secondary or secondary special. So what we see over here is secondary or secondary special is the segment who has been given most of the loans, right, and their default rate is also relatively high, though it is less than lower society, but lower society has been given almost negligible number of loans. Okay, but if you see what is the safest one, so here the higher educated people have been given the loan of somewhere somewhere 80,000, maybe 80,000 or 90,000 loans. 80 or 90,000 customers have been given the loans in higher education segment, and out of that the default rate is even less than 6%. Okay, so that is quite good because for this segment the rate of interest is somewhere 9%. Okay, more than 9% even, and this segment has the default rate even less than 6%. Okay, so this is a safest segment to give the loan. Okay, followed by, can we say, academic degree. Academic degree has been given the loan almost negligible number of times, so this is the safest segment. So what we can say is our conclusion will be higher education is the safest segment to give the loan with a default rate of less than 5%. So if you are getting the idea how do we do the analysis, because most of the time we struggle how exactly we have to do the analysis, from that perspective only I'm making this video, right, where the people struggle to understand. These are quite obvious thing, but we just do not figure out where exactly we have to start with and what exactly we have to analyze. So for those kind of people this video is created, right? So now possibly if you follow this you will get those understanding how the analysis is done, right? So that's what I'm trying to target over here. Okay, so now we are done with analyzing this name, education, type. How many variables we are done analyzing? 1 2 3 4 5 more to go. Okay, so here name, family, status. Okay, let me just write it down. Let me just see the definition of this: name, family, status. Okay, this is quite obvious what this particular variable mean, right? But still I would show you here. It simply means family status of the client. That means whether the customer whom we are giving the loan, whether they are married, single, or whatever it is. So let's just see. So most of the loans have been given to married people, followed by single or not married, and we can also say civil marriage kind of stuff, but the most number, we can say these two segment, right? Single or not married and married, this is the two segment who has been given the most of the loans, and to some extent this is also considerable civil marriage. So what is the total number of loans which has been given to this segment? Somewhere 25,000 customers are there civil, under civil marriage. But you see civil marriage has the highest default rate, which is almost 10%, right? If you look at this side, let's have a look at married segment. So married segment has been given the most of the loans, right, which is more than 175,000 or approximately 175,000. But the default rate, if you see, the default rate is somewhere 8%, somewhere 8% the default rate is for married person, which is quite less than with those compared to those who are civil marriage. Okay, both of them are married, but those who are civil married, I don't know what does exactly mean when it says civil marriage, not going to get into that. But yes, they have the highest default rate, and married has the lower default rate. Okay, widow has even less default rate, and people who are unknown have taken negligible, people who have unknown marital status have taken almost negligible number of loans, and their default rate is also not significant, even not visible over here. So what we can say is married segment is the safer one. And what is the number of loans has been given to widow? That is also very low, right? So married segment is something which is safe to target. Okay, let me just write over here, married people are safe to target. Default rate is almost 8%, 8%, almost 8, the default rate is almost 8%. Okay, now the next variable, this is going to be name housing type, whether the customer, let's just have a look at the definition of this variable, right? So what it says is name housing type. What is the housing situation of the client, whether he is rented or what it is, right? So that is also interesting one. Okay, let me just put it over here. So after we are done with analysis of all these things, we will final conclusion or the story kind of thing, right? So let's just say a name housing type, and let's go back to our graph, and over here we see most of the loans which have been given has been given to those people who has their own house or apartment. And what is the default rate? Rented people are having the highest default rate, which is approximately 12%, and those who have their own house or apartment, they are less likely to default. You see, they have somewhere 8% of default rate, isn't it? 8.1 somewhere. Okay, office apartments are also having less default rate, but you see the number of loans which have been given to them is too low. So what we can say is the loans which are being given to those people who have their own house or apartment are safer segment. Okay, so you see people having house or apartment are safe to give the loan with default rate of 8%, approximately 8%. So you see, mostly wherever the default rate is somewhere around between 7 to 8 or maybe somewhere 5% also are the safer segment. This is what the pattern we are getting. Okay, so let's just see next one. Here we have occupation type. What sort of occupation the people are doing? So most of the time the loans who have taken are laborers. They have the laborers, somewhere 140,000 laborers have taken the loan, followed by core staff, and then sales staff, and then managers and drivers. Okay, now let's just see who are the safest one. Okay, these 3 or 4 segment we see: laborers, core staff, managers, sales staff, and drivers. Let's see who has the highest default rate. So if you see over here, the low skill laborers have the highest default rate, but we can ignore that because the loans which have been given to them is too low in number. Okay, so we do not have sufficient numbers, so we can just ignore that. We can just say that we should not give we should not focus on this particular segment, or if we are focusing, we need to think on the rate of interest and all those things, right? So let's make a conclusion also, so that we can say whom to not target. Okay, occupation type, occupation. Okay, let me write in capital letter. Type. So what we can say is low skill laborers, low skill laborers are highest defaulters. No offense to this particular segment, but it's just I'm trying to figure out the analysis or the solution. Okay, now who is less likely to default? Those are accountants. Accountants are less defaulters. Okay, now because obvious reason, they are in accounting, they know the finance, they are quite educated financially. Now the people who had taken most number of loans are laborer. Let's have a look at their default behavior, where the laborer segment is. Let me just find that. Here it is, right? So if you see over here, they have somewhere 7.5% of default rate. Okay, that is still good, not bad. Okay, and after that, laborer, core staff, what is the default rate for core staff, sales staff, drivers, and managers? Let's have a look. Laborers we understood. Where is the core staff? Core staff has even lesser default rate. All right, so what we see over here is core staff even have even lesser rate of lesser default rate. Okay, and then the next one, managers, we had to see core staff and managers have almost equal default rate. HR staffs have also, HR staff, core staff, and managers, all these three have almost same rate of interest. Let's have a look at drivers, right? And where the drivers are. So the drivers are here. They have high rate of high default rate, so we should not target to the drivers also, right? So let me just write over here, low skill laborers and drivers. You see, the total number of loans which have been given to the drivers are somewhere 18,000 customers have been given, and out of 18,000, somewhere 11% are defaulters, which is too high, which is means comparatively too high. Who are safer? The safest one is core staff, managers, HR. What is the total number of HR staff have been given? Almost no number of loans, right? I mean, the number of customers are too low, so we can ignore that. Okay, let's ignore the HR staff. We will focus, we can say core staff, managers, and laborers are safe to give loan, right? Though laborers also have the relatively higher default rate, but comparatively higher default rate, but still we can consider them. So let's just say let's make our analysis. Core staff. All right, so let's just say that core staff and managers, we can say core staff, laborers are safer to target with a default rate of less than equals to 10%. Okay, 10%. Still, if we write 10%, that might not give the accurate picture. So 7.5 to 7.5 to 10% rather, we can say. Okay, so this is what the rate of interest, rate of default we are getting. I'm sorry, I keep on saying rate of interest. Just whenever I say rate of interest, just consider that I'm trying to say rate of default. Let's move to the next one. How many more we have? Right, so this is the second last, almost we are done. So weekday approval process start. Okay, so this is something you can ignore. I mean, this is highly, this barely make any difference. Even if you see at the default rate, how is that related to the default rate? When you are applying on Sunday, then is it that you are more likely to be a defaulter? You are less likely. You are I mean, those customers whose approval was processed on Sunday are too low, right? So this is highly going to make any difference. So let's just ignore this. Okay, next, which we're gonna focus is organization type. So here we will say organization type. Let's just see. And what does that mean? Let's just see what does that mean. Though it is very easy to understand what does that mean, but still, let's just have exact name, exact definition. Type of organization where the clients are working. Yes, so where the clients are working. All right, so let's just make it bigger. And if you see over here, so most of the customers who have taken loan are working in business entity type 3, and the number of customers are more than 60,000, followed by XNA. XNA is something you can ignore. Then over here, self-employed are the second highest. Then what you can see is business type entity 2. Then next one which you can see is others, right? So these are the customers who has taken most number of loans. And what is the status of their default rate? Let's just have a look at that as well. Okay, so here let's come back to over here. All right, so if you see, the transport type 3 has the highest number of defaulter, which is more than 15%, and the number of loans which have been given to transport type 3, it is too low, right? So whatever loan you have given to those customers, let's say there are only 1 or 2 thousand of customers, but out of that 15% are defaulter. This is not good. Okay, so what we can say is let's try to find a business entity type 3. What is their status? Where do we have business entity type 1, 2 and 3? This is still looking better, isn't it? It's somewhere 9%. Okay, 9.5% rather, you can say. It is less than 10, isn't it? It's less than 10. Okay, less than 10% business entity type. So this is good, right? Whatever loans, approximately 60% of the customers are from that category, and the default rate which they have is somewhere 9.5%. Still okay. Now the next type which we have is XNA, is something we have to ignore. Self-employed. Let's have a look at self-employed default rate. Where is the self-employed? Self-employed, just write that into the comment section if you just identified where the self-employed is. I'm still not able to see where the self-employed is. It is here we go, right? Self-employed. So this has default rate higher than business entity type 3, but still not the highest one. Okay, self-employed has somewhere little more than 10%. Okay, somewhere 10.5 we can say. Then after self-employed, what else that we have? Self-employed is the second one, and then you have other. For other, what is the default rate we have? Where is the other? All right, here we have the other. So others are the safest one. Okay, so let's just write our conclusion over here. Organization type, transport type, transport type 3, highest defaulter. Okay, then the safest one is trade type 4, but the number of loans are given too low, right? So what we can say is others are others, and then business entity type 3. Where is business entity type 3? Business entity type 3. And then the next one was, what is the next one? Self-employed. Self-employed was also okay, right? But still have more default rate, because people try their business, and if that fails, the loan also fails, right? Are good to go with. Okay, default rate around 10%. Okay, so we are done with all the categorical variables, right? So we are done with all the categorical variables, right? And here comes our final analysis, right? So as of now, this is with categorical variable. Now we will move to numerical variables, then we will do the bivariate analysis and many more. So many more to go, right? So as of now, this is it. You also try to write down your observation, and you can feel free to challenge my observations. I'll be very happy to read out whatever you observe, and just put that into the comment section. I will also learn, because like I said, this Learnerea channel is a platform for collaborative learning, right? So just feel free to put your observation into the comment. I'll be very happy to learn and read through that. Okay, I'll definitely reply on that. That we are done with doing the univariate analysis for the categorical variables. You remember previously we did the univariate analysis for all the categorical variables, and we wrote down our observations over here, right? So now the next thing is we need to move to the numerical variables, means the variables other than the categorical variables. So let's again have a look at those variables which are available in this particular data frame, right? So let's just have what all are the data types that we have available over here. Okay, so you see all these data types we had. Now what we're gonna do is we're gonna just take the summary of the data types. Okay, so value counts, you can just do this, and when you do this, I'm sorry, I just jumped to the other window. So when you do this, this is what you get. Okay, so float we have 18 variables, int variables are 15, and object variables are 10. Object is something which we have already analyzed, and categorical variables are somewhere 6. These are those categorical variables are those where we did the binning, right? So these are the binned variables. Now next thing which we're gonna do is we're gonna make a list of float variable, numeric variables in short we can say, right? So let's just call it var. Okay, numeric variables. So in numeric variables we're gonna consider only these two variables, and we will make another set of variables which would have all these three types of variables, which is float, int, and category variables, right? So let's just call it numvar first, and in that we're gonna say app score. This is the data frame name, and then we're gonna say select data types, and inside that we're gonna call include, and inside that we're gonna say float 64 comma int 64. Okay, so this will be our numeric variables. Next thing which we need to do is we will create another set where we're gonna say numcat variables. In this I will include categorical variables as well. So what I'll do is I'll quickly copy it from here, and I'm just going to put right over here. Okay, so now we have the list of all these kind of variables. Numvar, let's just see what all are the numeric variables that we got over here. Why is it taking too long? Okay, sorry, I just need to take the columns only, and here I'm taking whole data frame. Okay, so I will just say columns, and over here also I will say columns. Okay, now if you see, these are all the numeric variables. If you want to have a count of this, so you can simply say length. So here we go. Now the next thing which comes is selecting the data for these variables only. These are just list of columns. Now we will get the list data for these columns. Okay, so how can we do that? For that we're gonna say app score, this is data frame name, and in that we're gonna say numvar, this is the list of columns. Okay, so here we go, numvar. Okay, and let's just say head. All right, so here we got all the data. Now if you see out of it, in this we have one variable which is called target variable. This has the value 1 and 0. 1 means defaulter, 0 means non-defaulter. So out of this data frame we're gonna make two subset of this data. Let me first make a data frame which I would say num data. Okay, so this num data will have the all data for numerical variables. Okay, next thing which I would do is I will just take I'll make two subsets of this data. One subset will have only defaulters and then the other one will have non-defaulters. Why is that so? Why am I going to do that? Because this data is imbalanced. Number of defaulters are quite less. It is just 8%. If you want to have a look, what you can do is you can just say let's just say group by dot group by, let's just wait, it is going to auto complete it. Oops, it is taking group by, and inside that I will say target, and here let's just call size. So if you see, this is the total number of defaulters and this is non-defaulter. If you want to take a percentage of this, what you're gonna do is num data dot shape, and out of that just take the 0th element, and then what you get over here is the percentage of this thing. Okay, so if you see, this is just 8%. if you want to see exactly how it is, then just do this. So 8%, just 8% is defaulter, 91% is non-defaulter, right? So we're gonna make two subset. One subset will have only defaulters and one will have non-defaulter. So I will just say defaulters. I'm going to create a data frame which would be called as defaulters, and in the num data, and over here I would say target equals to 1. So this will be defaulters. Okay, this is going to give me the data for defaulters. Let's just have a look at top 5 records. So yeah, here we go. Here you would get only 1 in the target column. Okay, now I'm going to make a subset of repairs. Okay, here, so the same thing I will use, but it's just instead of 1 I would say 0. Now let's just see the head of this data. All right, so here we got the, now you can see in this, in the target variable you would have the value only 0. Now let's do the analysis of both of these two data sets one by one. First, let's just focus on defaulters. Okay, whatever the data set we have created as defaulter, if you see in that, what you have over here is, you see this these are all the defaulter data sets. So these are just 8% of the total data sets. So we're gonna just see how the variables are correlated to each other. What is the intensity of correlation for each of the variables, and we will find top 10 variables which are highly correlated. Okay, so that will help us to understand if there is a relation between, you know, the amount of income which a customer is getting and the amount of credit which he is getting, right? So we can say that we will be able to make a hypothesis that this a customer who is earning this much of the amount can be given this much of the this much of the, you know, credit amount. So that will be likely to non-default or default. So because here we are focusing on defaulters data, so let's just go through this and we will say that this type of customers can turn out to be the defaulters. Okay, now let's just try to make a correlation. So for that I would say core. So you see this kind of table we are getting, right? So let me just make a subset of this. Okay, and here what I will do is I'll take some variables, let's call it this, then I would say target. I'm just trying to show you a sample of it, and then I will take this, and then I will take this, just to show you a sample of it. Okay, let me just remove target. Target is not of much use. You see this kind of correlation you are getting. So if you observe over here, so what is happening over here? So you see this value is exactly the same, this value, this one is exactly the same as this value, right? this value is exactly the same as this value, and this value is exactly the same as this value. So in short, if you see, this is making two triangles with same values, which is not of much use. So what we can do is we will try to grab any one of the triangle. In this example, I'll grab the upper triangle. If you want, you can grab the lower triangle also. So when I grab the upper triangle, I would eliminate, remove lower and the diagonal. All right, so let's just go back to the Jupyter notebook over here. Let me just find the correlation of all variables. Here I was just trying, okay, let it be as it is. Okay, now here I will do it again. Defaulters dot head. So here is what you have. Let's just find the correlation again. The above one was just for sample. You don't necessarily need to do that. Okay, so here we got. Okay, so here you see target variable is not making of much use. So what I'll do is, while I'm creating a subset of the data, I'll drop the target variable. Okay, I'll just say drop target. All right, let's just see if that works. Oops, there seemed to be some problem. Alright, so the problem over here is I just need to say axis equals to 1. Right, now let me just take this and put with this as well. Right, so I'm just removing the target variable. That is not of much use over here, because we already know this is a separate subset of each of those two variable, each of those two categories. Okay, now here we don't have the target variable. Now the problem statement is to pick the upper triangle. Okay, how can we do that? All right, so first let me just create a table, or maybe data frame you can say, and let me just store it inside that. And here is what we have. Now the next thing which we need to do is pick the upper triangle. I'm repeating the same thing again and again, pardon for that. np dot once, this is what we're gonna say, np dot once, and then here you need to provide a shape, means array shape. Okay, what let's say you can use 2 by 2, 4 by 3, something like that. So here I'm just going to give the dimension of this table itself. Okay, so what is that going to look like? Here it is. Okay, now the next thing, we need to grab the upper triangle only. So for that you need to say np dot try means triangle, u means upper. Okay, np dot try u. Then over here you need to say, you need to create true and false. So for up here I would say k equals to 1. So what it will do is, for lower triangle it is putting 0, and for upper triangle it is putting 1. Right, so that means upper triangle is true, lower is false. So now you can easily pick the upper triangle. Here let's say here you can say as type np dot bool. Right, so you see here, the wherever you had 0, those are written as false, and wherever you had this 1, those all you can see as true. All right, now here I can say data frame name, which is this defaulter.car.where. This is what I'm going to do. All right, now you see, here is what you got. Now you must be saying that we are yet to grab the upper triangle. So we just need to filter, we just need to drop the NA values, right? So this is, if you have the table in this form, you can't do that. So for that we need to do this thing, unstack. You can say unstack, and then you're gonna get the data in this format. All right, now the next thing, we need to create the indexes, I mean the columns. So for that what you can do is, you can say reset index. So here is what we got. Now this column names are not looking good, so let me just rename this. Okay, I would say rename. Let's be cautious about the column names, and here you're gonna say columns, and here you just need to make a dictionary. All right, so in the dictionary I'm going to put the older column name, and then instead of that I want to say it var1. The same thing I will repeat again for the remaining variables. Okay, so here it will be level 1 and then var2. So this column level 1, I'm renaming that as var2. Next, and the last one is correlation. right? So this is correlation. Okay, so if you see, here is what we have, here is what we got. Now the next thing which we're gonna do over here is, let's just store it in a separate data frame, call that unstack, and inside that I'm just going to put this, and let's call it head. So here is a subset of that data frame. Now here we have one problem. You see how we transformed the correlation matrix in this way. Okay, now here we have one problem. Like you can see, core has NaN written a lot. Okay, so what we need to do is we just, and this would have some negative values as well. So first let's just make it absolute values, means we are not concerned about whether the correlation is negative or positive. What we want to find is top correlated variables. Okay, so for that I am going to say, call this particular function which is called ABS, and after that if you take the head of it, all right, so this is what you're gonna get. I understand you must be thinking still you see NaN, so for that what you can do is sort values, and inside that you just say ascending equals to false. Now if you see, ascending spelling seems to be incorrect, ascending, and here you need to say by core. Let's just see. Now here you got that. Okay, now what we this data still has the NaN value, so we're gonna just remove that. So you can just say subset, and when you do so in this data frame you only have sort values got an unexpected subset. Okay, let me just fix this. Oh, I'm sorry for this. Here it doesn't take the subset. Subset is something which is used in drop NA. Okay, so here we're gonna say drop NA, and inside that we can say subset. Don't get confused. All right, so let me just remove this if this is confusing you, and let's start from here. Okay, so you see NaN value. So what we're gonna do next is drop NA, and inside that we will say subset equals to core. All right, so here you are simply saying that subset the core and drop the NaN values out of that. Now let's just sort this, sort values, we're gonna say sort values, and inside that I would say by, and inside that I'm going to say core. This is the value, and then ascending equals to false. All right, ascending equals to false. This is what we can say, and in that we're gonna pick the top 10 variables. Like you can see here in the defaulters segment, the people who have this variable and this variable, these two are highly correlated with each other. Then amount goods price and amount credit is also correlated highly. Okay, so these are the top 10 variables which are highly correlated. You see, we did this analysis on defaulters data. Now the same thing we need to do on the second data sets, the second data frame which we have as repair, right? The same sort of thing you need to create on that data set, but for that what I'll do is I'll complete that. Okay, and then I'll pause the video and complete that, and then I'll show it to you. Okay, and I would say you try it yourself. All right, so here I just completed this thing for repairs as well, right? So it's exactly the same thing. What I did is I just changed the data frame name, right? So I paused the video so that it could remain concise. Now here also, if you see, the similar variables have the highest correlation, though the correlation value is different, right? So here you see days employed and days birth have the correlation value of 0.62. Same way, if you see over here in the defaulters data, we have that correlation for 0.58, means these two variables has little weaker correlation for the defaulters, while this has stronger correlation for repairs. Now that we are done with finding the correlation top 10 highly correlated numeric variables for the defaulter and for the non-defaulter segment, both of these segment, right? Next thing which we're gonna do is we again gonna have a look and find the relationship between the variables. So first we will start with, this is the correlation which we found. Now we will see, we will do the univariate analysis for each of the numeric variables. First we will do univariate, then we will jump to the bivariate analysis, right? We will just see how the numeric variables are related to default and non-default, and then how the numeric variables are related to each other. All right, lot of talking. Let's just see, let's just have a look at the variables which we have in num data. Okay, so we created, if you are following the series, you must have seen that we created this table which contains only the numeric variables. If you are not following the series, then here is the patch which is creating this particular data. Okay, now let's just come back over here and let's just have a look at top 5 records. Okay, so these are the numeric variables. If you see, this is id column, which is not of much use. This is just a flagging thing. Then this is showing the count of children. What is the variable that we should start with doing our analysis? All right, so if you see over here we have amount income total, amount credit, amount annuity, amount goods price, right? So you remember previously we had a list of numeric variables definition, right? So let me just see if I have that already opened. Looks like yes, I have it opened. Now let's just have a look at this. Let me just close this, and here, from here, what you can do is you can look for the definition of this columns. For example, amount income total, that means what is the total income of a customer, right, whom we are giving the loan. You can also say client or something like that. Amount credit, what is the credit amount was given to the customer. For example, amount annuity, right? So what does this amount annuity means? Let's just see its meaning, and for that what I'll do is I'll try to find the column over here. Amount annuity means loan annuity. What is the loan annuity that the customers are paying? Okay, and then amount goods price, amount goods price is something, this is the amount of the goods for which the loan is being given. Okay, for consumer loans, it is the price of the goods for which the loan is given. Yeah, it's exactly the same what I just said. Okay, so let's just focus on these amount variables and try to do the analysis on this. So what I'll do is I'll just copy all these variables, and I'll make a list of all these variables. For example, let's call it amount var equals to this. All right, so I'll just do it quickly. Oops. All right, so I just need to convert it to the list. That's why I'm sorry, I cannot do much into this. What I can do is either I can pause the video or I can do a fast forward, but it is almost done. Okay, so here we go. Now here we have the list of amount income total, amount variables. Okay, now let's just try to plot one variable. So for that I will plot, let me just do a KDE plot. Okay, SNS dot KDE plot, and in that data equals to I can say num data. I'm going to take the all numeric data, I'm going to take the subset of the data with numeric variables only, and on X variable I will just put let's put the amount credit, and let's just see what is it that we are going to get. And in the hue I will use target variable, so that it will give us an idea how the fraud is happening by amount, not fraud means default, how the default is happening by credit amount, what is the proportion. So if you look from the defaulter perspective, what we see is this line represents to the defaulter and this blue line represents to the non-defaulter. So if you see in both of the cases, the amount credit, most of the customers are falling in this range, which is 0 to 1 million. How do I know 1 million? Here you see L1E6, that means 1 to the power 6. So when you do 1 to the power 6, you get 1 million. Okay, so if you see, mostly the customers are falling between this range 0 to 1. That means those customers who took the loan of amount credit between 0 to 1. Some of them defaulted and some of them non-defaulted. Means what we conclude over here is mostly the customers who had taken were given the loan of 0 to 1 million, and some of them were defaulted, some of them were non-defaulted, few of them were defaulted rather, we can say. So we do not conclude much on the defaulter side over here. All right, so let's just repeat the same thing for all of these 4 numeric variables. Okay, so what we're gonna do is, how we're gonna do the automated, our favorite work, which is the automated way. All right, so let me just call for I comma call enumerate for I comma call in enumerate, and here I would just say this, amount var. Let me just call it amount var. Okay, and here what we're gonna say is plt dot subplot, and here I will just say we have 4 variables, so we're gonna create a grid of 2 by 2, and here I would say I plus 1. Then if you're following my series, you would understand why I'm doing this. Okay, if not, then I would recommend you just go back and follow the series, right? This is nothing but just I'm giving the dimension of grid, because here we'll be creating 4 charts all together. Okay, so sns dot kde plot, and in that here I'm just going to supply the data, which is nothing but num data. All right, and then here on x-axis I'll put columns, and then in hue I will put target. Let me just say target. All right, so we are done, but it's just some of the decoration which we need to do, that is plt dot figure, otherwise it won't look good. And here I would say fixed size, and here I would say 10,5, and over here I'll just give some spacing between the charts. Okay, plt dot subplot, subplot adjustment, and that I would say w space, which I would put 0.5, and h space I would put 0.5. Let's just run this. It will take few seconds, and then it will flash the charts, 4 charts, and then once we get the charts, we will start writing the insights, which we have been doing, you know, on this notepad. If you see over here, this is the notepad where we have done, where we wrote all of our analysis. Okay, let me just make it a little bigger. Okay, and here I'll just say univariate numeric variables analysis. All right, we got it. Okay, so now on these 4 variables, let me make it a little bigger. What you see is most of the customers were given the loan, most of the customers who were given the loan had income between 0 to 1 million. How do I know this? Simple. 1e8, you see this, that means 1 to the power 8, which will be 100,000, right? So each number multiplied by 100,000, right? So somewhere it will if you expand this will come between 0 to 1 million. Okay, so most of the customers who took the loan and turn out to be non-defaulter have total income between 0 to 1 million. Okay, now amount credit, which, okay, first let's focus on this particular variable, amount goods price. So most of the loans which has been given, for that the goods price was between 0 to 1 million, means mostly the loans which were given, for the product which had a price of 0 to 1 million. Okay, so let's just write this makes some, you know, sense over here. Let me just say most of the loans were given for the goods price ranging between 0 to 1 million. Okay, now because the loan is given for the goods price, so if the goods price is ranging between 0 to 1 million, of course amount credit would also range between 0 to 1 million. This would somehow be related, not exactly. Look, not always the amount credit would be in sync with goods price, because let's say sometime if you are taking a car loan in India, So somewhere 90% will be finance and 10% you will have to do the down payment, right? But that somewhere range between the same ranges around the same amount. Okay, so if the goods price is ranging between 0 to 1, amount credit would also range between 0 to 1. So this is this we can, if you want, you can write it. Most of the loans were given for the amount credit amount of 0 to 1 million. All right, 1 million. Now let's have a look at amount annuity. So mostly the customers are paying annuity of 0 to 50,000 rupee. Okay, most of the customers are paying annuity of 0 to 50,000. Okay, most of the customers are paying the annuity of 0 to 50,000, and mostly the customers have income between 0 to 1 million. All right, so mostly the customers are falling, you can say, falling under low income, right? On defaulter side perspective, we cannot conclude much basis on this amount variables. Like I said previously, that defaulters and non-defaulters both are ranging between 0 to 1, 0 to 1, 0 to 1, and in the same segment. Okay, so if you take a segment over here 0 to 50,000, this has defaulters and non-defaulters also. If you could have a case that between 0 to 50,000 you are getting this line, and this line is has a spike between 100,000 to 150,000 over here, then we can say that customers paying low annuity are the defaulters, right? But it's not the case here. If you see, non-defaulters are also paying the annuity of 0 to 50,000, and defaulters are also paying the annuity of 0 to 50,000. Same goes with goods price and the amount credit. So we do not have much to conclude basis on the defaulters from the defaulters and non-defaulters perspective using these variables. Now that we are done with doing the univariate analysis for these specific variables, where we chose amount variables specifically, now let's go ahead and start with doing the bivariate analysis, and that we will perform again on the numeric variables. So let's just have a look at the data first. Let's call it numData.head, and let's have a look at the variables. What are the variables that we can use for our bivariate analysis? So if you see over here, this is ID variable, which doesn't have much sense. Then the target variable, this is simply flagging which customer is the defaulter and which one is non-defaulter. Then here we have count of children by each of the applicants, then amount income, amount credit, amount annuity, amount goods price, etc, etc, etc. All right, so let's start with amount variable again, right? We will do the bivariate analysis with amount variables itself. So what does bivariate analysis means? That means over here we are trying to find the relation between two variables. We are doing the analysis basis on the two variables. Means, let's say we will use amount income and amount credit, and basis on these two variables we will figure out what is the relation and how they are influencing to the default behavior. Okay, whether the customer is going to be defaulter or non-defaulter. So to do this kind of analysis we can use scatter plot, pair plot, etc. Let's start with a simple example where we will be using a scatter plot. Let's say SNS.scatter plot, and okay, let's just first pick out the or maybe let's just take out all the data. That's all right. SNS.scatter plot, and in that data equals to, I'm going to use numData, and on x-axis I will be using, look, amount credit and amount goods price will always be correlated. Okay, let me show you a glimpse of it. Okay, so here amount credit, and on y-axis you're gonna put amount goods price, and then I will use hue parameter, and here I will use the target variable just to see the influence on this particular thing, right? So here what I'm expecting is we will have a perfect linear correlation, rather I can say, right? Because see, if your goods price is higher and if you're getting a loan, of course along with the goods price, your amount credit will also increase, right? Because let's say if you are buying a loan of buying a car of 1 million rupee, right, then of course you would require somewhere, you would be getting a finance of somewhere 80,000 or something like that, or let's say if you something around that. Okay, so that's how, you know, that like you can see here you have a linear relation between both of these two variables, because like I said, if you are buying a costlier product, you are tend to get the costly more, you know, if you're getting a loan, the loan amount will be more than the one where the goods price is less. That's pretty obvious. All right, so over here the conclusion which we get over here is in bivariate analysis. Let me just write it down over here. I will say bivariate analysis. Please ignore if I just make some spelling mistake, if I do some typo mistake, because here we are majorly going to be focused on our analysis. All right, so we can say that amount credit and amount goods price are correlated, linearly correlated. All right, and the second point, if you see, if the customers are taking loan of less than 1.5 million, they have in this segment we are getting many of the defaulters. These orange points, if you see, most of the defaulters are in the segment of, you know, this less than 1 million. Wherever amount credit is less than 1 million, over there we have most of the defaulters. Okay, if the amount increases, the defaulters are also decreasing along with that. Okay, and amount goods price, of course, like we observe that amount goods price and amount credit is linearly related, right? So this is our observation. Okay, if you want, you can write down that if the amount credit increases, the defaulters are decreasing. All right, but that doesn't mean that we can start giving the more amount to the customers. Of course, that will depend on the, you know, income and all those things, right? Basis on that, we cannot make the conclusion that let's give the more amount. Okay, so let's try to have a look, try to find a correlation with amount income as well. Okay, not correlation, but the bivariate analysis, rather we can say. So here we will be trying to figure out how does the amount credit, I mean, what sort of loan amount are given to which income segment. Okay, let's just see. So if you see over here, let's just give it few minutes. All right, so if you see over here, let's have a close look. So this is the amount credit, okay, and this is the income. So if you see income, wherever income is more than 1 million, the people are not taking the loan, which is quite I mean, loans loans are not given, they have not been given the loan, which could be quite possible. If someone is earning more than a million, why would they go for this kind of loans, consumer loans, right? Of course there could be certain exceptions, but mostly, like, you can see the analysis. Okay, so what we conclude is the people who are earning less than a million are most likely to take the loan. Now, what segment of that are likely to be defaulter? So the people who are earning less than a million, and if they are taking a loan of less than 1.5, there could be there could be possibility that some of them will turn out to be defaulter, because after 1.5 almost you have nothing, almost there are no defaulters. All right, so this is what we conclude. Okay, let's just write. So the people having income less than or equals to a million, 1 million, are more likely to take loans, out of which who are taking loan of less than 1.5 million could turn out to be defaulters. Okay, so people who are earning less than a million, and if they are taking the loan of more than 1.5, they are less likely to be defaulters. So this is our segment which we can target. Okay, so what we can target is, we can target income below a million, 1 million, and loan amount greater than 1.5 million. Of course, other factors will also matter, like whether they have their own house, how many number of children do they have. Okay, so those all things will also matter. Let's try to put count of children over here and try to do the bivariate analysis. Okay, let me just put it over here, and let's just see what sort of loan they are getting. Okay, how much amount are they going to get? Scatter plot, because the data is huge, that's why it is taking a lot of time. Okay, all right, so what we observe over here is, you see here the number of children are 0, and you see most of the defaulters are falling in this segment. So what we can say is, people who have no children, and if they are taking a loan of less than 1.5, they can turn out to be irresponsible, right? They can turn out to be irresponsible, and they can turn out to be defaulter also, right? So that's how they can turn out to be defaulter. So we can say people having 0 children are safe to give, and if they are taking a loan of, means of course depending on their eligibility, if they are taking a loan of more than or equals to 1.5 million, they are safer segment. Okay, other than that, if the people have children more than 0 and less than 5, if you see more than 0 and less than 5, people having 5 or more than that children, they are turning out to be defaulter. You see over here this is disastrous. Okay, then over here also they have more default, there are more defaulters. So what we can see is, people having children 1 to less than 5, right, between 1 to 5, people having children 1 to less than 5, of course we can say, let's call it less than 5, are safe to give the loan, are safer to give the loan, right? Because see, if they have the kids, they will be kind of responsible, right? Rather, I would say the most safest, safest segment is 1 to, I can say 2.5, and then this will be 3, 1 to 3, right? You can say that. So when the people get children, they become more responsible, right? So they will pay the loans on time and they will not default, so that they want to have their good CIBIL score and everything, so that they could get the loan whenever they need. Of course, if they have family and children, they are more responsible and they might require financial support at any point of time. That's why they become cautious, right? So that's what we conclude out of it. So you see how we are performing the bivariate analysis. So this is something which we are doing one by one. There is a way you can use to do it all at once. For that, let's just pick the amount variables. I'm just going to perform that on all the amount variables. From here, I'll just pick it, and let me just say amount var, and over here what I'll do is I'll just say num data, all right, and out of that we will pick this, oops, this. Just bear with me while I'm making it suitable enough. Looks like I made some mistake over here, and then it comes over here. All right, and there is one more variable which I would like to include, and that's gonna be target variable. Okay, so this is done. There seemed to be some problem. I just need to use double square bracket, and here we go. Okay, so we got this data. Now let's just plot this SNS pair plot, and into that we are going to use data equals to amount var, all right, and then we are going to use hue equals to target. Let's just see what happens. All right, so here we got our pair plot, right? So many of the things which we have already observed or analyzed, let's focus on each of them, try to find out the most valuable one. Okay, so if you see, this particular row is representing to amount total income, and this particular column is representing to amount credit. So for example, if you see this, and it is this particular plot, this is the intersection of amount credit and amount good price, which we previously discussed. Of course, that would of course have the linear relation. Okay, now let's have a look at amount annuity and amount credit. Okay, so the people who are so see, where do we have the density? So the most dense area is this one. So the people who are capable of paying annuity, amount annuity of 100,000, you see here, this, they are getting the loan of somewhere less than equals to 2 million. Okay, so people who can pay the amount annuity of 100,000, right, 100,000, they can get the amount credit of somewhere approximately 2 million, right? And defaulters are also in the same segment, but still that's the highly dense area where the people have taken the loan. Of course, in some of the cases, along with amount annuity, amount credit is also increasing, right? Like you see, if the customer is able to make more amount annuity, they can get more amount credit, which is quite obvious, right? If you are able to pay more EMI, you can get more credit. Okay, that's one thing. Okay, then over here, if you see amount annuity, so again amount good price, so this is highly related to amount credit. So both of these graph will look identical. Okay, so like you can see over here, this amount income relation we have already observed, and then again this comes amount credit. I think we have already observed all these plots, right? But this is the way you can do the bivariate analysis for multiple variables at the same time. Now here what we observed is, let's write it down, people who are earning, people who can pay the annuity, who can pay the annuity of 100k are more likely to get the loan, and that's up to less than 2 million, the safer segment. Okay, we will call it the safer segment. Similarly, there are many other numeric variables. Of course, we cannot cover all of them as of now, otherwise the video will be too long and you will be bored and you will stop watching it. Okay, but my purpose is to give you the idea and give you the confidence how you can start, how you can do the exploratory data analysis. You see how we are doing it and how we are making the inferences out of it. Same way, I encourage you to go ahead and do the bivariate analysis with we just did it with the children count. I would say just go ahead and do it with age variable basis on days birth. We had created some categorical variables, age grouping, right? So I would say just go ahead and try that. Age variable, days employed, basis on days employed, you should try that, right? And you should try to find the relation between couple of the variables, right? And write down your inferences. Whatever you write down, just put that into the comment section so that I will also learn, right? There is high possibility that there could be something more important which I am missing, but yeah, just go ahead and do all those analysis and put that into the comment section. I will definitely have a look and I would learn from that and I would reply on that. Okay, that we are done with doing the bivariate analysis of the numeric variables, rather I can say some of the numeric variables. Now the time comes, if you remember, initially we discussed that we would be having two data sets. One is current application data set and the other one is previous application data set. So now the time comes to explore the previous application data set, and then we will see how we can derive the combined analysis out of these two data sets. So let's start with this. Okay, so we are going to do the similar thing. First we will explore the data, we will check out what all are the features available, then what all are the missing values, what all are the variables which have missing values, and how to and impute the missing values accordingly, and then further proceed with the analysis. All right, but don't worry, to save the time and to keep the video concise and to the topic and not to make you lost, what I have done is this time I will be writing less codes, rather I will be doing the copy paste so that we could be more focused on the content part. All right, so let's just start with checking out the missing values first. All right, so for that what I have done is I have already codes written over here. So what I'll do is I'll just check it out. Okay, so it will be little slow, you gotta bear with this, okay. So now that we are done with creating the things, let me just have a look on this. Okay, let's just have a look on this. In the meantime, I'll close these two programs and just write over here. So what you see is these are the variables in previous app data frame. Here comes the previous app data frame. I have simply taken the percentage of missing rows in this data frame by each of the column. This is something which I have done step by step for current app data frame, which is this one. For this data frame I have done this step by step. You can refer to the previous videos. All right, so here like you can see, we got the list of all the variables by percentage missing values. Okay, so here you see these are the variables which have maximum number of missing values. So what we did previously. So we will pick out those variables which has the missing values more than or equals to 40%, and then we will see how to drop them and all those things, right? So let's just first pick out these variables out of it. Okay, so for that I have written this code, and this will just give us a list of columns, these columns which have missing percentage more than or equals to 40%. Now the next thing is to remove these columns from the data frame. All right, so let's just check it out. Okay, all right, so these are the columns which have missing values greater than or equals to 40%. Other than that, there are some more variables which are not of much use. What are those variables? So I have done the analysis, I have done the exploration of those variables, and these are the variables I found have not much use, right? So if you want to understand, just pause the video and read out the definition which we have written over here. Okay, now so I will try to combine these variables with this list, and then at the end we will try to drop them all. Okay, so how to do that? So for that, what I will be doing is I'll create a variable which is called NVA calls. NVA calls means non-value add columns. All right, so let me show you the list of NVA calls. Here comes the list of NVA calls. So in this, if you see, these are the variables which has missing value greater than or equals to 40%, and these are the variables which I decided to drop basis on the analysis, the definition of the variable, rather you can say. Okay, so if you take the length, number of variables, how many variables are there in total? There are 15 variables. 11 variables with missing value greater than or equals to 40%, and 4 variables which are not of much use. Let's move forward and let's try to drop these variables. Okay, so how can we drop these variables? Before dropping that, maybe if you would like to have a note of all the variables which we have in our data frame. So the total number of variables that we have are 37. Now let's just try and remove the variables. So here what you see is this is the line, this is the patch of code which I am using to drop the columns. Like you can see here, I'm using, this is my data frame, and here I'm using drop, and in labels I'm passing the list of these columns which I have created over here. Axis is nothing but just I'm trying to say that these are the columns. Okay, and this will be the data frame which would have all the columns except these 15. All right, and then we will see how many columns we are left with. So we are left with 22 columns. What those columns are, what all are those columns? If you want to have a look, then you can do this. Here is what you got. If you want to see the data, then what you can do is just simply say head, and here we got that. All right, so this is how we get the variables which are going to be useful for us. Now the next thing which we're gonna do is check out what all are the variables, what is the missing values now we have in the data frame. So for that, what we're gonna do is we're gonna just have a look on this. Let's have a look. Here is what we got. All right, so these are the variables which have the missing values in majority, right? So amount good price, amount annuity, count payment. Count payment means number of installments or number of months, for how many months the loan is given. Okay, then here comes product combination, right? So this has very low percentage. If you want, you can ignore this, or we can just continue with this. Okay, that's highly going to put some impact over here. All right, so here is the other variable which is amount credit, which has extremely low missing value, so you can just ignore that. You can feel free to ignore that. Let's see what next that we gonna have. So we will start with the variables one by one. First thing which we're gonna start with is analyzing the goods price, amount good price. Okay, so let's just have a look here. What I'm trying to do is I'll just try to find the mean and median of this particular value, right? So if you see, the median is 112,000 while the mean is 227,000. That means the data is skewed. That's because simply it is saying that whatever the number of records that you have more than all right, so 50% of the records are below 50% of the loans have good price less than or equals to 112,000, then how come mean can be 227,000? All right. Well, then it clearly shows that certainly there are outliers in the data frame. In this particular variable, there are outliers because see, mean or median are highly, different. Okay, so let's just figure out how can we treat those missing values. So what we will do is we will try to find mean, median, mode, everything, and we will see what fits well, right? And then we will see. Okay, so first of all, I will try to fill the missing values using median. So what I'm doing is in the data frame I'm creating one variable which is called amount goods price median. So by like the name itself suggests, median suffix means here we are filling the missing values using the median. Okay, so this is done. Next thing which we're gonna do is we're gonna try to fill the missing values with mean, and then another thing which we're gonna do is fill the missing values using mode. Now that we are done with filling the missing values, next thing what we're gonna do is we're gonna get a list of all these columns, and then we will try to create a plot for all these columns. So here you see this is the original variable which would have the missing values, then here is median, and then here is mean value, fill missings filled with mean value, and then here missings fills with mode value. Now let's try to plot all these variables and see which of these three looks identical to this one. Whatever looks identical to this one, we will use that. Okay, that's how it makes sense. This is a very interesting analysis to fill the missing values, right? Because here we are simply trying to see whatever of these three are looking identical to this, we are using that only to fill the missing values into it. That's how our data almost remains balanced. Okay, so for that what we're gonna do is we're gonna plot them all over here. All right, so this is the script which I have already written, and then I will just plot this over here. This will take some time to show you the graphs. Just bear with this. Until then I'll all right, so here we got our plots created, right? So let me just make it a little bigger. So what you see is this is the original variable amount goods price, and this is the median, this is mode, and this is mean. Mean is of course out of scope. If you see over here, mean is obviously out of scope because see this is different. It has two big spikes, right? While our original data has just one big spike, and that is touching to 6 million approximately. Median looks pretty identical to this, right? Approximately 6 million with one spike. Amount goods price mode is also identical, but somehow it is exceeding to this is density, right? So not exactly. Okay, so here it is somehow exceeding to 8 million. So what I'll do is I'll go ahead with filling the missing using median. All right, so because see mean is of course out of scope, the only thing which we are left with is either median or mode. I choose to go ahead with median. I would highly encourage you to try this using mode and see how does it behaves in your analysis. Okay, so let's just start with, so here is the patch that I'm going to use to fill the missing values. All right, and we are done. We are done with filling the missing values in this particular variable. If you don't trust me, what you can do is you can just take this and say is null, and then you can simply say sum, and here is what you get: 0 missing values. There is no missing values. Okay, now the next thing which comes in is amount annuity variable. All right, so let's just check out the amount annuity. So in amount annuity, again we're gonna find the minimum maximum. Why do we do this? Amount annuity has the missing values that we understood, and that was approximately 22% amount annuity, right? And amount annuity is something that's the annual payment which a customer can make, right? So we are just trying to figure out what is the mean, median, and max, which will give us the idea if the data has certain outlier basis on which we can choose which one of these we should use to fill the missing values, or we should choose neither of these three. Okay, so let's just have a look. here is what we get. So mean is 15,955, median is 11,000, and maximum is 418,000. Okay, though mean and median are looking little close to each other, these are close to each other, right? Still, so I think we can use these things to fill the missing values, right? So let's just see what fits well. Okay, so here is the code that I have already written. Like you can see over here, mean is somewhere 15,000 and median is 11,000. That means again we are saying that half of the population are below 112,000, sorry, 11,250 amount annuity, right? They are paying the amount annuity of less than equals to 11,000, right? But how come mean is coming to this 15,000, right? Again, there seem to be some outliers in the data. So again, what I'll do is I'll go ahead and use the median to fill the missing. Okay, so let's just do this. Here I am done with doing so. Alright, so now we are done with filling the missing values in amount annuity variable as well. Next thing which comes is, after filling the amount annuity, the next thing which we're going to look at is product combination. Let's first have a look at the values. What are the values that we have in this particular variable? Okay, so let's say, you know, head. So these are the values which we have. So like you can see, this is the categorical variable, so we cannot perform mean, median, minimum, maximum, etc., right? So what we can do is, in this case, we can simply use the mode to fill the missing values, right? So here it says POS mobile with interest, cash, Excel, etc., etc., right? So here I will simply use the mode to fill the missing values. Okay, so let's just try. Though this particular variable has very less number of missing values, so if you want, you can manage to ignore this as well. Okay, this had just, okay, let me just show it to you how much of the missing values. It has just 0.02% of the missing values. Okay, I mean somewhere 0.02%. Okay, so this is what the missing values it has. All right, so if you want, you can just try to manage to ignore that. Okay, next thing which we are left with is, after amount annuity, what is the variable? Count payment. This is going to be interesting. Okay, count payment. All right, what is count payment, CNT payment? Let's just first understand what CNT payment is. So I'll just take you over here, and in the list of description I'm just going to put this terms of previous credit at application of the previous application. Okay, let's just see what does this mean. Okay, terms of previous credit at application of the previous applications, right? So this is simply saying for how many months the loan was given. Okay, so let's just try to understand this variable in more detail. Okay, let's just try to explore this particular variable. So here what I'm going to do is, I will just check out. Okay, let me divide it in the pieces first. Okay, so what I'll do is, let's just see let's just see the analysis. Okay, first of all, let's just take this, and over here I will just use this product combination, not product combination, rather count payment. Okay, this is what I'm going to use over here. So if you see, these are number of months, right? Mean is 16 months, median is, I hardly believe that some loan is given for 16 months, median is for 12 months, max is 84 months. All right, but see, the problem over here is, this is we require to do some more analysis on this part. There is one variable which is called name contract status, which is simply saying that whether the previous application was approved, declined, refused, or cancelled, or whatever it is, right? So we're gonna have the two-dimensional analysis on this particular one. Let me just, okay, this is similar one. All right, so let me just see. All right, so here you see for count payment we got this numbers. Okay, and all right, so here what I have done is, There are two variables which I have considered. One, count payment, which is simply telling you the tenure, and this is the status of the application for the previous application. Okay, so here it simply shows that in the previous application data there were these many applications which were cancelled. So what you see is majority of the applications are getting cancelled. So if you use either mean, median or max to fill the fill the missing values, that would have wrong impact on the data, right? I mean incorrect influence on the data. All right, because see, this number will highly influence that, because in the mean this will have significant contribution, right, which does not make much sense. Similarly, refused also, or something like that, right? Most importantly, cancelled is something which is going to be non-value add. Okay, so that's how I would suggest that let's just fill the missing values in this particular variable using 0. All right, so here we will use 0 to fill the missing values. Okay, so now we are done with filling the missing values. Now that we are done with filling the missing values, let's just have a look at the count of missing values once again, and then see what are the variables that have missing values. None of the variables have the missing values except amount credit, which is just one record with missing values, which we can simply ignore. That's not required at all. Okay, if you want, you can just fill that with using the mean if that data does not have any outlier, or maybe you can use 0 to fill that missing value. Ideally it won't be 0, so either use, because amount credit cannot be 0. Okay, so you see, if the status, if this particular status is not cancelled, then you can try to put median into that. Okay, just if you are interested in filling that. Okay, otherwise you can simply ignore. Now after that, the next thing which comes in over here is, you remember here we created many variables for our analysis. These 3 variables which we created for our analysis, which are of not use in the data, we just created it to check out the analysis, right? Do our analysis to fill the missing values. Now the time comes to drop them from the data, right? So let's just drop them. Those are dropped. Next line, in the next step, what we're gonna do is we're gonna find the missing values. Now let's just see what is their status. Now again we got the same, and along with the missing values we also wanted to drop these variables. So after dropping those variables, the list of variables which we final list of variables which we have is this, and after that I'm just going to show you the number of variables that we are going to work with. They are just 22. In the previous application data frame we have only 22 variables to work on. Now what we will do next is, in the next step we will do the analysis, and then we will try to merge this data with the current application, and on the current application we will try to derive the conclusion or inferences using the historical record, right? That's going to be very interesting. That we are done with merging the data and doing feature engineering, feature selection on the merged data. It's time comes to do the analytical work, right? So let's just have a look. There are some useful variables which I observed. Let me just show you that. Contract status. Let's see this name, contract status. So if you have a look at this variable name, it says contract status approved, cancel, etc. So this is simply telling you previously when the current applicant, when he previously had applied, what happened with his application. That's what it is simply telling you. Okay, so this would be having the value like approved, cancel, refused, unutilized, etc, etc, etc. Okay, other than this, so this is something which I will be using in this analysis. Okay, now other than that, if you see, we already have a variable which we say target variable. Okay, this is very much useful, which simply says whether the customer turned out to be a default, the current application customer, okay, whether he turned out to be a defaulter or a repair. Okay, now after that there is one more variable which is let's just say cash name, cash loan purpose. what was the purpose for which the loan was applied. So this is in previous data set, right? In previous data frame we have a variable which simply tells you that for which purpose customer had applied the loan, and the variable which I just show you, contract status, that tells what happened with the application. Okay, now let's just filter out all those variables which we just highlighted. So three variables: this name cash loan purpose, what was the purpose for which cash loan was taken, what happened with that application in the past, and currently in the current application data set, when the customer got the loan, utilized the loan, what he did he turn out to be a defaulter or a repair. So these are the three variables which are going to be focusing on primarily over here. All right, let's just start with this. Now over here, let's just say SNS dot, I will simply create a count plot, SNS dot count plot, and data equals to merged df, and over here on x-axis I will be plotting, let's call it this one, name cash loan purpose, and in the hue I want to put this status, which will simply tell us what happened when he had applied for this purpose. And over here this will simply create the plot. Now after that we need to do some sort of decoration, let's say plt rotation, we will have to perform the rotation, otherwise it will just overlap each other. Okay, plt dot xsticks, let's say, and rotation equals to 90 degrees. It will simply rotate the labels at x-axis. Okay, now after that plt dot y scale, we also need to use log in scale, otherwise the values would not be very clear. All right, let's just try to plot this and let's just see how does it looks. Okay, so this is going to take some time. I'll pause the video and then we'll resume once it appears. All right everybody, so we got our plot created over here. So while the video was on pause, I added one more line just to make the plot little bigger and clear. Okay, so if you see over here, these are the contract status. Okay, let me make it little more bigger. So these are the contract status, which means when customer had previously applied, either it was approved, cancelled, refused, or unused. Okay, so now let's look at the data. So if you see in the data what happened, these are the purpose for what was the purpose for which the customer had previously applied for the loan. Here there are two values which you see, xap, xna, just ignore that, we don't have clear definition for that. Now if you see others, after these two, if you see, then repairing is the purpose which was given the highest, which had highest amount of low application, rather we can say, and out of that the same category had highest percentage of, I could say the percentage, but still if you see over here this orange line, it shows the cancellation, right? So in this segment proportionately the applications were immensely cancelled. Okay, so we can say that repair purpose was something where the application were mostly cancelled, and this was the segment which had most number of application. After that, if you see there, what else do we have? Like you can see over this one as well, then this one, this also has more number of cancellations. And if you see, then what is the red color? Unused offer. So unused offer in other segment also, many of the applications were approved, but I mean many of the applications were unused. People didn't utilize the approvals or maybe the loan sanctions or something like that. They didn't went ahead for the offer. Okay, those turned out to be unused. Okay, now what else that we have to see over here? Buying a new car, that is also one thing. And what else that we have? these are the things which we see mostly available. Okay, so let's make the inference out of it. What is it that we observe over here? Where we observe repair is the segment which had maximum number of applications and the cancellations. For the repairing purpose, customers had applied mostly previously, and the same purpose has most number of cancellations. Okay, this on this we will get more clarity as we progress. So this is something where we saw what was the purpose for which the customer had applied and what happened with that. Now let's see whatever cancellation happened. For example, if you see here, we have 4 categories. Whatever status was previously, right, whatever this decision was previously taken on a particular application, what happened when customer applied again, right? Let's just try to figure out that kind of solution. Okay, sns dot count plot again, and in this time we are going to use data. Of course it will remain same, merged df, and on the x-axis this time we are going to use name contract status, and in the u we are going to use this time target. You see, now this time what we're gonna get is this chart will tell you whether what happened when previously customer had applied and what happened when he again applied for the loan, right? I mean, not applied for the loan, when he took the loan after that. Okay, like usual, it is again taking some time, so I'm going to pause the video and we will resume again. Alright everybody, so here we got our plot. Now let me just make it bigger, and what you see over here, previously the applications which were cancelled or refused, if you see in the current scenario, most of them, in fact we can say approximately more than 80 or 90% of them are turning out to be repair, right? So we can make a inference that it's not necessary when the customer was previously cancelled or refused a loan, right, he will turn out to be a defaulter always, right? So what bank can do is whatever cancelled applications or refused applications were there in the previous segment can reanalyze that and try to offer the loan to the bank. Okay, so let's just write this. Most of the applications which were previously either cancelled or refused, 90% of them, 80 to 90% of them are repair in the current data, you can say, right? This is one decision we can make over here. If you want to see this in terms of number, what you can do is you can say merged df, right, dot group by, and in this what you can take is this variable name contract status, and let's put it in the quotes, and in here what you can put is target, and then you can say size, and here we got it. All right, so here you see the here it simply says whatever applications were previously applied, out of that these many are repair and these many are defaulter. Let's try to convert it in terms of percentage. Okay, we will try to convert that in terms of percentage. For that let's first do reset index, and let's see what happens. This is how we get. Then let's just rename it, rename columns, and over here I will just rename one column which is 0, and I will say counts, right? Let's just see, this is what we get, and I will just store this in a table. Let's call it merged aggregated. Okay, and this is something which I'm going to put over here. Now I need to convert that into the percentage. So what I need to do is I need to take sum of these two and then divide each of these two separately. So how can I do that? For that, what I can do is I will just say merged agg dot group by, and inside that what I'm going to use is this variable. All right, over here I'll use this variable, and then over here I will take counts, and on that I'll perform sum. Let's just see what happens. Okay, this is what we are looking for. Reset index over here. All right, so this is what we got. Now what I need to simply do is I will merge both of these two. I'll just store this in a sum df. I'll just say sum df, and then I'll merge both of these two, and then I'll divide and I'll get the percentage. Okay, so what I'm going to do is let's just say pd dot merge, and in that I will say merged agg comma sum underscore df, and then how this is going to be left on this particular variable. Right, now let's just see how does it looks like. Yes, we got it as we wanted. So we will say merged agg, let's say call it 2. Okay, merged agg 2, and in this is what we get. Now we just need to find the percentage of it. So what we can say is let's create another variable, let's call it percentage, and after that what I can do is I will simply say merge this. If this is something which you find boring, you can just watch this in 2x speed, and then maybe you can, or if you want you can skip this part as well, right, because this is just taking time. So I'm just trying to tell you a way how you can find the percentage of this, right? So this will give you the decimal places that you can fix by doing a round, and in that over here I will just use 2 decimal places, and then I will just try to print this. All right guys, so what we see over here, in the cancelled 90% of the customers turned out to be repair, 9% turns out to be defaulter. In refused, 88% turns out to be repair, and 12% turns out to be the defaulter. Okay, now there is one more analysis which you can do. You can include purpose into this. I insist you to do that yourself. You can include purpose over here, and you can see in the cancel segment for what purpose customer took the loan previously, who turns out to be the repair this time. Okay, previously they were cancelled, but they are turning out to be repair this time. That's something which I insist you to do yourself. Okay, right, so this is something which is giving us a picture in terms of numbers, clear picture in terms of numbers. All right, so this is what we can conclude. Mostly 90% of the customers in all of the cases except refused, in all of the cases 90% of the customers are turning out to be repair. In case of refused, only 88% of the customers are turning out to be the defaulter. So almost we can say 90, because 88% is quite close to 90%, right? So if you take average, it will turn out to be 90%. So we can say 90% of the customers turns out to be the repair, even if you take a cancelled, refused and unused offer in that also. All right, so looking at the unused, I just got one more idea. What we can do is we can check out one more thing. SNS dot, okay, let's just make inference out of it, though we have already written that. Let's just start, let that be. Okay, SNS dot, let's create a line plot, and in that we are going to use data equals to merged df, the original one. Okay, and over here on x-axis I'm going to use this one, and then on y-axis I'm going to use the income variable. Okay, let me try to find the income variable. This one, amount total income, this variable I'm going to use on y-axis. So this will tell me what is happening. Okay, this can turns out to be, all right, so we will just try this. This can be, because you know when we merged that, this can turn out to be not giving the appropriate information, but let's just see what does it have to say. And in this line plot you get chi square created by default, so I'm just going to say it none. Okay, and let's just see. Alright, so while the video was paused, I added one more parameter, which is this. Okay, now here what we see is, let's try to observe this. Here what we see, in approved and cancelled and in refused, we mostly see the customers are repair. But when it comes to unused, previously where the offer was unused, customers are highly defaulting into that, despite of having high income band. Okay, despite of having a high income band, they are turning out to be the defaulter. So the offers which were previously unused, now in current application they are turning out to be the defaulter. So this is the conclusion we can make over here. Previously offers which were unused previously now have maximum number of defaulters despite of having high income band customers. All right, so this is our conclusion. All right, so now what we're gonna do is I'll you know just keep it till this point only, right? Because still there are many variables, and if we want, we can perform many more analysis and we can do much more out of this data. We can find many other inferences, which I highly encourage you to go ahead and do, but for now I am going to keep it till this point only. Now this is a lot, right? So out of whatever variables we have, approximately how many variables? Let's say merged df dot columns, and let's take a length of this. So we have 70 variables, right? And using 70 variables, these are the insights which we have derived, right? We will keep to this point only. Now in next video, what we're gonna do is we're gonna summarize all this analysis and try to reach to a conclusion out of it. Okay, but if you want to do more analysis, you are most welcome to go ahead and explore the other variables. You will come up with very effective strategy out of that. Okay, but I'm going to keep my analysis till this point only, and in next video I'm going to summarize this all and will try to take you to a conclusion. Now that we are done with analyzing our data, we did the analysis on current application data and on the previous application data. It took a whole lot of time. All right, now is the time comes when we should make our final conclusion, right? Final conclusion, and or maybe you can say insights. We need to make our insights, right? So you remember, while we were doing our analysis, we were taking the note of each of the items, right? So here is what we have noted everything. Now basis on this, we are going to make two things. If you read the name over here, I'm saying recommendations and precautions, right? Two things I will be trying to derive out of these comments. So let's just focus on recommendation. Let's start with recommendation, and in between we will keep on writing the precautions as well. Okay, so here, like, we can start from here, or maybe we can start from the bottom, right? So what I'm going to do is, you can, okay, so like if you are following the video, you must have also prepared these all kind of pointers, right? What I would recommend is you just pause the video and use these comments and write a specific story basis on this. That what, when I say story, that means the recommendation basis on these pointers. Write your own recommendation that what a bank should follow, and be rest assured this is not the live project which you are doing in your company, right? So here is the place where you can do practice, take risk, take chances. If you get shy, if you hesitate, if you procrastinate, then it's not gonna help you, right? So just pause the video, and whatever pointers you have already written, just use them and write your own story, and then come back over here and try to see how I am making this story. I'm damn sure you're gonna make recommendation much better than what I am going to do, right? Trust me. All right, so once you are done with making your story, put that into the comment section. I will definitely have a look on that, and I'll give a thumbs up and a heart to that. Okay. All right, so I just hope that you are done with your story writing. Then let's continue from over here. Okay, so here what it says is most of the customers have taken cash loan. Customers who have taken cash loans are less likely to default. That means we can recommend a bank to focus on giving the cash loan to the customers. Then the point comes, whom should the bank give the cash loan? So here there are many pointers, but I am going to start from here. How did I decide that I will be starting from here? Because I once went through all the pointers and then I made my mind where to start from. Okay, so here is the point where it says the income part. Okay, so let's say here it says amount credit and amount good price are nearly correlated, which is very obvious, so we will not go by this much. Then here it says people having income less than or equals to 1 million are more likely to take loans, out of which who are taking loans of less than 1.5 million could turn out to be defaulters. We can target income below 1 million and loan amount greater than 1.5 million. I'm not sure how safe it will be, because if a person earning 1 million a year, then giving 1.5 million, not sure, but so I would not like to go with this point, right? So let's come back over here. People having children 1 or less than 5 are safer to give loans. That makes sense. People who can pay annuity of 100k are more likely to get the loan, and that's up to less than 2 million. This is also okay. Now over here it says most of the loans are given for the goods price ranging between 0 to 1 million. That's very good. Most of the loans are given for the credit amount of 0 to 1 million. Most of the customers are paying annuity of 0 to 1. Mostly the customers have income between 0 to 1 million, right? So this is the our recommendation. I'll start my recommendation from here. Bank should target the customers who, now here comes my pointers. All right, here, who have income around 1 million, who have, what we can say, bank should target let's say low income. We can say that low income customers, and here we can give an idea, having income below 1 million. All right, so the people who are having income below 1 million, bank should target to those customers, okay, to give the loan. Now what is the credit amount that bank should target to give them below 1 million? The credit amount should not be more than 1 million. Okay, this is what my recommendation is. Then annuity can be made of 50k depending on the eligibility. Ignore about the spelling if there is something incorrect. Now why I said eligibility, sometimes it happens customer is having some loan of 1 million and at the same time they are having other EMIs also going on, so we should evaluate, bank should do the evaluation on that part, but bank can target to make annuity of 50k. okay, here that's what my recommendation is. Now here comes, mostly the customers have income between 0 to, this we are done covering over here. Bank should target low income customers. The credit amount should not be more than 1 million. Annuity can be made of 0 to 50k. Then let's go upward. What else? Okay, then we are not going to be much focusing people who pay annuity, or we are not going to be much focusing, or I am not going to be much focusing on this segment. Then otherwise what we can do is we can also say people who can pay the annuity 100k are more likely to get the loan, and that's up to less than 2 million. All right, so let's go upward, and over here it says the people who are transport, okay, so this will be precaution. Transport type 3 organization, transport type 3 organization should be avoided. Organization transport type 3 should be avoided. You see I'm writing it in precaution. Okay, then organization type over here, what I'll do is I'll take this point from here and I'll write down over here. Okay, they so here what I'm saying is the credit amount should not be more than 1 million, and annuity can be made of 50k. Low income customers can be targeted, and then what else? Customers having low income, we can say customers having low income, and then we can make some more points from here. Okay, and over here customers having low income, working in having org type, or maybe we can say working in org type. All right, this is one. Then after that, here we can say that core staff accountants are less defaulters. Core staff manager to target with default rate of 7.5 to 10%, right? So what we can say is core staff managers and laborers are safe to target. Okay, we can say this. Accountants, including accountants, working as accountants, core staff, managers and laborers. Okay, and then what next? Low skill laborers should be avoided, and drivers should be avoided. Okay, should be avoided. All right, then next comes people having house, apartment are safe to give the loan. Where it is now, sorry, please bear with me, I just clicked somewhere. So here people having houses and apartments, so then again this having house and apartments, and then married people are married and are married. Okay, and here we can say kids were also there. I had just seen the number of kids. Children, count children, I had taken that analysis also. Children count not having more than name type suit, name income, name education type, family status, housing type. Where is that? Children. Here, people having children 1 to less than this point, right? Having children not more than, and having children not more than 5. This is what having house and apartment, and married, and having children not more than 5. Okay, these are safer segment. Then we had family status, married people. Then here comes highly educated, having higher education, highly educated, we can say higher education, or we can, let's make it more personal, highly educated. Then what comes next comes our segments are working commercial, associates, and pensioners. Working professionals, which we have already written over here, right? So commercial associates, and pensioners can also be targeted. So like we have over here mentioning working in others, business entity type. So this more or less covers the same thing. Okay, so I'll just skip on this part. Okay, then here comes unaccompanied people had taken most of the loans, and the default rate is this one, 8.5%, right? So here this we can take as a separate point. Unaccompanied people can be safer. Okay, this I'm keeping it separate. And over here highly educated is done. Default rate for female are just 7% approximately. So here I would say preferably female, right? So what else? Now customers who have, and focus on customers having income. Bank should focus, or let me focus on bank should target the customer. The credit amount should not be more than 1 million. This is not making a better story, right? So what we can say is, let's take this point out from here and put it down somewhere here. Okay, I'll try to make a good story. Bank should target the customer having, this also is not fitting well over here, so let me just put like this: customers, bank should target the customers, having, okay, let me just make it like this, having low income. All right, so bank should target the customers having low income, working in others, business entity type 3, self-employed, organization type, working as accountants, core staff, managers, and laborers, having house or apartments, and are married and having children not more than 5. They if they are highly educated, that's the safer segment. Preferably female if they are preferable. Now what should be the bank what should be the amount segment? Then we can say amount segment recommended. Okay, so here what we can say is, this is not, of course we can put it over here. Okay, sorry, what I just did. Okay, let's make this amount segment recommended. Annuity, the credit amount, yes, the credit amount should not be more than 1 million. Annuity can be made of 50k, and low income I have already given. Income bracket could be between 0 to 1 million. Okay, of course 0 is nothing, but yeah, 0 to below 1 million. Rather we can say income bracket could be below 1 million, let's say below 1 million. Okay, so this is what my recommendation is to the bank. Okay, so what I'm recommending, simply what is the story that I came up with? I'm simply saying target to those customers who have low income, that means below 1 million. They must be they must be working professionals, and they should be working in if they are working in any others organization or in a business entity type 3, or if they are self-employed if they are working in any organization type which is others business entity type 3 or self-employed, that's the safe. If they are working as accountants, core staff, managers and laborers, then that is safe. Remember, here I am not targeting those customers who are in field work or lawyers or something like that. Those are slightly riskier segment. Okay, if the customer is having own house, and if he or she is married and having children not more than 5, that's a safer segment. And if the customer is highly educated, that is going to be more safe. And if the customer is female, that's going to be much better. Okay, then if the customer is unaccompanied, that is turning out to be more safer. If you want to mention numbers also, let's say if the manager asks what is the number, right, then you can say default rate is approximately just 8.5%. okay, this is what the default rate is, right, for the unaccompanied person. Now what should be the amount segment? Then this should be the amount. This is how the amount should be planned. Okay, and what should we avoid? We should avoid transport type 3 organization, right, and low skilled laborers should be avoided. This is what I conclude out of the analysis which we did so far. Okay, so I will just mention it over here, precautions. Okay, and I'll just put it here. We had written down the pointers while we were doing the analysis after merging the previous month data, previous application data and the current application data. So what we observed was most of the applications which were previously either cancelled or refused, 80 to 90% of them are repair, right? So what we can say is bank can consider to give loan to those customers. Bank can do the analysis and can, or let me write it this way, right? So I would rather say 80 to 90% of the customers, 80 to 90% of the customers who were previously cancelled. When I say cancelled means their applications were cancelled or refused. Okay, are repairs. So what bank can do is bank can okay, just bear with me. Bank can do the analysis and can consider to give loan to these segments. Okay, this is my observation from the previous application. What next? Offers which were unused previously now have maximum number of defaulters despite of having high income and high income band customers, right? So this is something which we can mention in what to avoid, right? So here I'm going to say applications previously unused, offers previously unused and high income customer should be avoided, should be avoided. So those customers who are highly earning and they unused their previous offer should be avoided over here. So this is our final analysis. This is what I would recommend to the bank to do, right, basis on supported by numbers what we just got over here, basis on our analysis. All right, from that. Okay, thank you very much for watching the video. Wish you very good luck, and we will start a new series on a next topic, next interesting topic. Keep on watching this channel. Thank you very much.